A magnitude 15 earthquake has the potential to completely destroy our planet and evaporate all the water in a matter of seconds, leaving Earth uninhabitable. Over 500,000 earthquakes happen annually, but none have a magnitude of 15. 90% of quakes occur in the terrifying Ring of Fire zone located around the Pacific Ocean. The ground there is like jello. It shakes almost constantly. The most powerful earthquake to have ever struck Earth had a magnitude of 9.5. That much power can lengthen or shorten the day. But there's probably an earthquake in the confines of your own home now caused by a speck of dust landing on a table. But it has a power of negative 15 magnitudes. Earthquakes happen when tectonic plates move. They're like Lego pieces that are not properly secured, and when they move up, down, or hit one another, the ground also moves, triggering earthquakes. This tectonic energy acts like a battery. It stores energy for a long time, up to 500 years. When this stored energy is released in a sudden burst, the consequences are horrifying. Even the strongest structures submit to this relentless force that leaves a trail of destruction in its path. In some instances, earthquakes can even trigger tsunamis, amplifying the chaos. Such a crazy amount of power can split the ground open and cause severe damage. The strength of an earthquake is measured by the Richter scale, but now it's being replaced by the moment magnitude scale. When there's an earthquake, we hear about how strong it is. It's usually from 1 to 10. Luckily, we haven't had a Richter scale earthquake yet. The most powerful earthquake to have ever happened in modern history occurred in Chile in the 60s. It was around 9.5 on the Richter scale, and it altered Earth's rotation and messed up the length of the day by around 2 milliseconds. It also triggered a massive tsunami and affected a vast area of 155,000 square miles. The Richter scale doesn't actually have a limit. Still, anything above 25 doesn't need measuring, because if that ever happened, we would simply turn into dust, and nobody would care to measure this disaster. As we said, the strongest earthquake had a magnitude of 9.5. If this magnitude had been just 0.5 stronger, it would have created a ruptured line 2,174 miles long. That is almost 7 times the size of Wyoming. A magnitude 11 earthquake would create a crack halfway around the world. Massive tsunamis would hit coastal areas, destroying everything, and Earth would get into a massive environmental crisis. If you love hiking, you would have new mountains to explore, created by the terrifying earthquake. Even the temperature would increase because of volcanic eruptions and the resulting greenhouse gases. It would turn our planet into a hot oven. The safest places would be far away from any buildings, seas, oceans, and mountains where there would be a low chance of a landslide. Countries unprepared for earthquakes would be totally destroyed, and cities would turn into piles of rubble and dust. Going up on the Richter scale would only make things worse. But don't worry, an earthquake of that power is impossible. Earth's crust doesn't have enough energy to produce such earthquakes. But there is something that has much more power and can produce mega earthquakes. Asteroids are powerful enough to destroy our planet, as we all know from the dinosaur era. That asteroid was around 6 miles long, and it caused massive damage to the planet. It triggered earthquakes that shook the ground constantly for months. These terrifying quakes were about 50,000 times stronger than the Chile earthquake. They also triggered a tsunami that was 30,000 times more powerful than the Indian Ocean tsunami. And the latter was one of the most devastating tsunamis to have ever struck Earth. The earthquakes caused by the asteroid had a magnitude of 11, making it the most powerful and scariest natural disaster ever. And let's hope it stays that way. The Indian Ocean tsunami affected only certain areas of the world. Meanwhile, the asteroid tsunami affected every part of the world and had 33-foot-tall waves. Even if you had traveled to the most remote place on Earth, you wouldn't have been able to hide from this Grim Reaper. A 15-magnitude earthquake wouldn't be 15% stronger than the Chile earthquake. The scale doesn't work like that. It would be around 100 million times more powerful than a 9.5 magnitude quake. It could make all the water on Earth evaporate, leaving us devastated and without any H2O to survive. All ecosystems would collapse, all food chains would be broken, and only some super strong bacteria would probably survive the impossible. That is only a fraction of the frightening things that could happen. The ocean is like the AC for our planet. Without it, Earth would be super hot. The ocean also serves as a shield from the sun's powerful rays. It acts as a heat absorber and cools Earth. Scientists think that the most dangerous thing would be the inability of Earth's crust to survive the violent shakes of the 15-magnitude earthquake. If our planet miraculously survived and didn't turn into dust, there would be massive openings in its crust. The ground would become gelatinous. It would randomly move up, down, left, and right, and no building would survive that. Our civilization would be brought back to the Stonehenge era. Tectonic movements like this are devastating. A similar thing happened in Japan when tectonic plates moved 165 feet from each other and then snapped back together, creating a 9-magnitude earthquake. No place on Earth is immune to this bone-chilling natural phenomenon. Still, certain places have higher chances of being destroyed than others, like the Ring of Fire, where 90% of earthquakes happen. This is a place where earthquakes are almost everyday occurrences. The Ring of Fire is located in the Pacific Ocean. It forms a ring around the continents that surround the Pacific. There, several tectonic plates meet, creating highly unstable ground. To make the problem much more terrifying, 75% of active volcanoes are located in this area. 90% of dormant volcanoes are also there, making this place extremely dangerous. Scientists carefully study this region to find a way to predict when the next earthquake might strike. The Ring of Fire is not the only place at risk of earthquakes. In California, along the San Andreas fault line, 2 tectonic plates have been storing power for more than 200 years. The San Andreas Fault is 715 miles long and has the potential for a massive earthquake. This region has its fear of violent earthquakes like the one that happened in San Francisco in 1906. It had a magnitude of 7.8 on the Richter scale. Scientists' predictions are terrifying. They say that the chance of a 6.7 magnitude earthquake is very high in the area. If all hell starts to break loose, you should know how to survive. Avoid anything that might fall on you, like windows, closets, or unstable ceilings. The official phrase from emergency experts is drop, cover, and hold on. Stay low to the ground. Hide under something stable like a table, and remain there until the shaking stops. Make sure to stay in your shelter for another minute or two, just in case there are aftershocks or loose debris. Use your nose and smell for gas. If you do smell it, don't turn the lights on or do anything that might ignite it. Stay strong and be safe. You rub your eyes, trying to make sense of everything. Perfect circular holes in the bottom of the ocean floor off the coast of Big Sur in California. You have no idea how this happened, even though you're a marine biologist who's been practicing it for years. You go through some of the old records and find out that these holes have been around since the 90s. In 1999, a ship-mounted sonar conducted a survey and found 5,200 of these pock marks, or large holes over 500 square miles, on the ocean floor. They look like moon craters underwater. You contact your team and get the robot ready to go down and explore the scene and bring back a few samples. You and the team drive to the coast and hop on the boat. You're sitting inside controlling the robot with a joystick. Your teammate sets the robot in the water and drives it down. Everything seems normal near the surface, but as the robot goes lower, the pockmarks start appearing. A bunch of boats swift past you, making you lose your balance and focus. The robot turns on the flashlight so you can see better. But as it goes lower, the resolution is less crisp. It almost reaches the bottom, and the holes are smooth and nearly perfect circular shapes. Some of these holes that were visible in the sonar reading measure more than 30 feet across and 15 feet deep. You show the rest of your teammates the images, and they're shocked. The robot continues swimming, but there appear to be more holes all around. many of them are too small for the scanner to capture from above. These microdepressions are steep and have sort of tails going in a certain direction. It's possible that the currents underwater played a role in their shape. Everywhere the robot swims, there are new holes all around. After a couple of hours, the robot goes back to the boat with some samples. You take them back to the lab and study them. The robot clearly captures images of human trash, but the samples don't indicate anything alarming for now. Despite the fact that 1/3 of the pockets are filled with trash, there's still no explanation of how they were formed. It's late at night and the rest of your team heads back home. You're passing out in the lab, still trying to find some answers. You wake up the next day and while cooking breakfast, you get this idea that maybe these holes are gases venting out, which could be harmful to marine life. You quickly get the robot and sail out to the ocean once more. This time, you didn't even think about calling your teammates. You place the robot in the water and get behind the screen to control it. The robot descends to the bottom of the ocean and does a survey. So far, the holes still seem to be covered with trash. But some of the holes have marine life dwelling inside, like fish and seaweed. After much scanning, it doesn't look like they're producing any bubbles, which means there aren't any gases venting out, but you're determined to find them. After a while, you reach one of those large pock marks, and the robot starts scanning around. You find some bubbles coming from a source, but the robot can't reach it. It swims around trying to find a spot, but nothing. You bring the robot back to the lab and work on it. You attach some mechanical arms on it that can lift things and move them. You bring the robot back down to the same spot, but the bubbles aren't as frequent as before. You use the arms to move some of the trash and find out that the bubbles are being produced by a group of crabs chilling next to a pile of plastic. Bingo! The bad news is, you still don't have a clue why the microdepressions and pockmarks exist. As you try to control the robot to go back to the surface, an octopus wraps its tentacles around it, pulling the robot down. You struggle with the controls and push it to maximum power, but the suctions of the octopus are too strong to break off. It's a game of tug-of-war with the octopus and your robot. It takes the robot under a pile of trash, thinking it's lunch. But you use the arms to maneuver the robot out and swim back to the surface. You go back to the lab even more confused. The robot has collected more samples for you to study. Your eye is glued to your microscope, trying to figure out what's going on, but nothing. You decide to do a carbon dating test to determine how old these holes are. After a while, you check out the results and are even more stunned than before. They show that the holes are around 400,000 years old, so it's likely that human trash wasn't the cause for all this. You pull many all-nighters trying to figure out the truth. You gather your team once more and hold a small press conference about this. You claim that this may be something we should be extremely worried about, but you still can't tell them more than what you know. With all the brain work put together, you find out that the large pockmarks haven't changed or been active for more than 50,000 years. The newer holes were most likely created by human trash settling in the bottom of the ocean floor. The marine life gathered some of this trash like plastics and discarded fishing gear and created homes for themselves. This is why around 4,500 of the holes are newer and have trash in them. But it still doesn't answer why the holes appeared in the first place. You're back to square one. The only way to see what's really going on is to clear up the trash from underwater and study them. The story makes headlines in the local community and catches the attention of a cleanup crew. You organize a trip to the ocean and begin the extraction of all the trash. Many cleanup boats arrive and everyone drops down a net to collect the trash. You send down the robot once more to make sure the nets are hitting the right spot. As most of the trash is being collected, many marine life animals scramble and try to find a way to escape. Everyone makes sure not to hurt them. After a couple of weeks, all the holes are cleared up from the trash. You do another sonar scan from the surface and can see the holes clearer than before. But you still don't have an answer for this. You do some more research trying to see if any other holes appeared around the world. On the other side of the country is a mysterious blue hole off of Florida's Gulf Coast. You catch the nearest flight to Florida and make an appointment with the scientists in charge of the expedition. Blue holes are underwater sinkholes that open below the seabed. Just like on the surface, the underwater world also has sinkholes. This one is called the Green Banana and is 150 feet below, and the hole is 435 feet deep. You dive with some special gear with the rest of the team to a barren ocean floor, and the hole is right there in front of you, looking like an oasis in the desert. You and the rest of the scientists are surprised by the diverse marine life dwelling within. Some sea turtles swim past you, and even sharks. These ones don't harm humans. Halfway through, you reach a narrow path, which makes it difficult for humans to pass through. But everyone is careful. There are corals, sponges, mollusks around the corner. You collect some samples and go back to the lab. Blue holes in general are richer in nutrients than barren lands and host plenty of unique marine life. They're quite common and don't pose any sort of threat to anyone. After making the connections, you don't think the holes off the coast of California have anything to do with blue holes. The mystery goes on.
Rocks rolling down the slopes of a rumbling volcano, pushing other bigger rocks on their way, and eventually tumbling down into the ocean in a humongous cascade, causing a wave the height of which the world's never seen before. This is what might happen if the Helena slump of the Hawaiian Big Island falls off into the water. The Kilauea volcano is far from dormant. The latest eruption occurred in 2018. Its eruptions are usually accompanied by earthquakes of different magnitudes, and with each quake, the magma rocks on the slopes of the volcano shift down. These rock formations are called slumps, and the Helena slump is the most notorious of them all. In 1868, the shift of this slump caused a tidal wave rising as tall as 60 feet. But what's most troubling is that some 110,000 years ago, a landslide here led to one of the most powerful earthquakes ever, which in turn led to a mega tsunami of over 1,000 feet in height. Scientists are worried that such an event may repeat in the future. If that happens, the wave might engulf the whole of Hawaii and easily reach both North and South American coasts. Geologists are quick to reassure, though, that a landslide like this is unlikely to occur anytime soon. It's just too early for that. But when it finally does, the consequences will be catastrophic. Have a nice day! Yellowstone National Park in the western USA is world famous for its dazzling views, and especially the colorful Grand Prismatic Spring at its very heart. But we should all stay aware that Yellowstone is, first and foremost, an enormous caldera, basically a slumbering supervolcano. The difference between a regular volcano, like Kilauea from earlier, and a supervolcano is that the latter is thousands of times more powerful. Imagine an eruption spewing tons of huge rock and rivers of hot lava, pumping out clouds of ash that make countries stop air travel for weeks. And now multiply all of this by 1,000. This is what a Yellowstone eruption would look like. At first, a huge area in the middle of the national park would shake, crumble, and then blast upwards in a megaton explosion. Lava flows and magma rocks would cover the area of about 40 square miles, roughly half of Washington, D.C. But the greatest danger is the volcanic ash. The ashen plume would rise miles above and get carried by the wind in every direction. Since the eruption would be far from ordinary, the spread and damage would also be much greater than usual. The ash is thick and heavy, so it would cover a vast area in a blanket, destroying crops and even buildings. Worse still, it would spread in the air and block out the sun, leading to a drastic drop in temperature and an artificial winter. Even regular volcanoes can lower temperatures worldwide by a few degrees. A supervolcano may potentially cause a new ice age. Luckily, the chances of Yellowstone supervolcano erupting in the near future, or at all, are extremely low. There have been only 3 of those in the history of Earth, and there's no evidence such a disaster should repeat. Scientists estimate the probability at 0.00014%, which is lower than the chances of an asteroid wiping us all out. Speaking of which, If dinosaurs could talk, and were at least still alive for that matter, they'd tell you that asteroid threat is as real as it gets. Scientists at NASA say they've tracked 90% of all near-Earth asteroids of significant size, and none of them are a matter of any concern. But there are still the other 10% in the great unknown. What's more, asteroids can change their line of flight because of the pull of other celestial bodies and eventually turn our way. Lucky us! Now, if an asteroid big enough, like a mile across, hits the Earth, it will first cause an explosion powerful enough to erase a dozen big cities in a matter of seconds. Then the impact will raise a cloud of dust and debris that will block out the sun, just like the ash cloud from a volcano, and cause a centuries-long winter on the whole planet. But even if it falls into the ocean, which is more likely, a resulting wave will rise several miles high, washing coastal cities off the face of the planet. But at least there won't be a new ice age. Although scientists are pretty sure there's no such threat in the near future, it can't be ruled out completely, and humanity needs at least 5 years to prepare for this event. If a big near-Earth asteroid suddenly changes its course and turns right toward our planet, we won't stand a chance against it. Disaster movie, anyone? A much more probable calamity, though, rests right beneath our feet. It's the San Andreas Fault in California. The fault has been ready for rupture for years now, and scientists estimate that an earthquake along this line is likely to occur in the next 3 decades. And when it happens, it won't be nice. They expect a magnitude of 8.0, which is comparable to some of the most devastating quakes in history. It's all the more dangerous since California is home to some of the most populated cities in the western U.S., including Los Angeles and San Francisco. High-rise buildings are common there, and they're particularly vulnerable against underground shakes. The San Andreas earthquake might cause a whole lot of damage both to cities and countryside. In the worst-case scenario, the ground might break apart, destroying buildings, farms, and changing the landscape altogether. Still, scientists believe that the probability of such a quake is only 7% for the next 30 years. So there's a rather big chance, 93%, that we'll never see that in our lifetime. Yet, there's another earthquake hazard not so far away from the previous one: the megathrust in Chile. The country sits right above the subduction zone, an area where 2 tectonic plates meet and go one beneath the other. At the place of their meeting, stress has accumulated because of their continuous movement, and once that strain is too much, a major earthquake occurs. Chile has experienced a lot of quakes in the recent years, and scientists are worried those might be preparing the area for a really big one. They believe a great earthquake is due to happen before the end of the century, and it might be devastating to the coastal area. Even smaller quakes cause tsunamis that flooded the west coast, and a huge one like that is likely to raise a wave of incredible height. On the bright side, Chile now knows to prepare in advance for the coming natural disasters, and geologists are pretty sure people will be able to evacuate before the earthquake strikes. In September of 1859, astronomer Richard Carrington was looking at the sun and suddenly saw a bright flare on its surface. He made a note of it in his records, but only realized how important it was a couple of days later. The energy from that flare reached Earth and struck it directly, causing northern lights to appear above Cuba and burning telegraph lines all around the world. This was dubbed the Carrington event, and it was a solar storm. Such storms hit the Earth fairly often, but none of them were so powerful as the Carrington event, neither before nor after. But in 2012, astronomers registered a similar solar flare whose energy nearly hit our planet once again. If it had been just a week earlier, we'd have been in big trouble. Today, humanity relies on electricity in almost every aspect of life, and a powerful solar storm would mess with the electromagnetic field of Earth a lot. All electric appliances would either shut down or short-circuit, and huge transformers powering basically everything would go out of order for good. It would take years to repair them, and the cost of such a massive blackout would count in trillions of dollars. The worst of it is that science is almost unable to predict solar storms, and even if we could know about them in advance, we'd be powerless to stop them. The flare happens in a matter of seconds, and it takes about 8 minutes for the particles to reach the Earth's atmosphere, causing the disturbance. The power outage would come a bit later, in a day or so, when a massive cloud of plasma gets to our planet. At the moment, there's no protection against solar flares, and the chances of one powerful enough to cut all of our electricity in the next few years are quite high, about 12%. The only good thing about all this is that we now know of such a possibility and can at least prepare in advance. Hey, don't forget to pack some underwear and socks. You'll always need those.
If you think you're safe from violent tornadoes because you aren't living in the tornado alley, you could be dangerously wrong. It's shifting to the east. It looks like we're about to see fewer single tornado days and more days with multiple powerful tornadoes. And because they're shifting into more populated areas, they could take more lives and ruin more homes. There isn't enough time to build infrastructure to protect everyone from this fast-moving danger. So the least you can do to save yourself is learn as much as you can about it. About 1,200 tornadoes hit the US every year. You gotta thank the unique geography that sets up the perfect conditions for it, especially in spring and summer. Winds from the Pacific drop moisture over the Rockies and become dry and cool as they move east. They collide with warm, humid air streams from the Gulf of Mexico over the flat terrain. And that's how unstable air and wind shear, which are the perfect conditions for tornadoes, are born. Historically, tornadoes were most common in Tornado Alley. This term was first used in the 1950s by two meteorologists as the title for their research project to study extreme weather in Texas and Oklahoma. Northeastern Texas and south-central Oklahoma are precisely the areas we think of when we talk about Tornado Alley. But in the past 10 years or so, it has shifted eastward by up to 500 miles. Now, eastern Missouri, Arkansas, western Tennessee, Kentucky, northern Mississippi, and Alabama see more tornadoes. The storms of early 2023 are great proof that this trend is real. A violent tornado hit Rolling Fork, Mississippi, and another outbreak caused huge damage in the new Tornado Alley. Data from the past 2 years shows that large tornado outbreaks with multiple twisters from a single weather system are also moving eastward and becoming more frequent and intense. The Tornado Alley is shifting eastward mainly because of supercells. Those strong thunderstorms with rotating updrafts create new tornadoes. Supercells form when warm, humid air near the ground interacts with cool, dry air higher up. You can say that we're living in the middle of a natural experiment. We see changes in the basic ingredients for severe storms. But we don't know how significant these changes are. Experts predict that supercell storms will become more frequent in the late winter and early spring and less common in the late summer and fall. The air in recent years is getting warmer and moister, and the interactions between air masses more and more common. Experts explain that the atmosphere is becoming more unstable and the Gulf of Mexico sends more water vapor into the southeastern U.S. All these factors fuel the storms. Research also shows that the so-called dry line, which divides the wetter eastern U.S. from the drier western U.S., is shifting eastward too. This line has traditionally fallen along the 100th meridian, but has moved about 140 miles east since the late 1800s. This shift can affect where storms form, as the dry line works as a boundary for convection, where warm air rises and cold air sinks, fueling storms. Milder winters we've seen recently also mean more opportunities for unstable air masses to interact and form supercells earlier in the year. It's tricky to predict how the situation will change and how dangerous it is, because we don't have that much data on how weather patterns affect such short-lived events as tornadoes. The U.S. National Weather Service only began keeping tornado records in 1950, and they didn't catch many tornadoes in remote areas. Data shows that the number of days with tornadoes each year has decreased, but there's more tornado activity on those days when they do occur. The records also show that some years, tornadoes take the lives of up to 20 people across the U.S., and in other years, they take over 100 lives. But now, there are more people living in the paths of tornadoes because the U.S. population has more than doubled since 1950. And the Southeast, where tornado activity could go up, has way more residents now. Texas and Oklahoma are well prepared with tornado shelters, but areas in the southeast are less equipped. Plus, there are many mobile homes in the southeast which are vulnerable to windstorms. Tornadoes in this region often strike at night, and they are 2.5 times more likely to cause fatalities. We could possibly have more events like the 2008 Super Tuesday tornado outbreak. It hit the southern US and lower Ohio Valley, and over just 15 hours, 87 tornadoes rushed through the area and caused massive trouble. 57 people lost their lives across 4 states and 18 counties, and many others were injured. The tornadoes were fueled by strong low-pressure systems that brought record warmth. There were supercells and rotating winds that produced these violent tornadoes. Early on February 5th, a squall line developed from eastern Texas to Missouri and moved east. One of the most intense tornadoes traveled 122 miles over 2 hours. By the early morning of February 6th, the severe weather threat shifted to the eastern U.S. It caused wind damage as the cold moved out to the Atlantic, with snow and freezing rain from Iowa to Quebec. It ruined many homes and even swept some of them from their foundation, made mobile homes fly, blew many vehicles and tractor trailers off Interstate 40, and threw some cars on trees. There were wind gusts over 50 miles an hour from Arkansas to Indiana, hail the size of softballs, toppled trees, and power outages everywhere. Some areas were flooded because of heavy rains and melting snow. All this led to over 1,000 flight cancellations at Chicago's O'Hare and disruptions at Toronto's airport. The data from scientists can help new areas of the U.S. prepare for more tornadoes coming their way. The people in authority will also need to improve community shelters and warning systems and educate the locals on tornado safety. You can also get prepared by learning 3 basic rules: get in, get down, and cover up. When you hear the warning for an upcoming tornado, get into the most interior room in your house and stay away from doors and windows. If you have a basement or an underground tornado shelter, hide there. If not, just be on the lowest floor possible. You can use whatever's at hand to protect yourself from debris. Clothing, pillows, blankets, a mattress, or a bulky table. Anything will do. There's a tip that says that the bathroom is the safest place to hide. It makes sense because those are mostly right in the center of homes. In March 2023, a man and his girlfriend in Rolling Fork, Mississippi survived a tornado in their bathtub. It got thrown into the air but landed safely amid the wreckage of their mobile home. But there's actually nothing extra safe about being in a bathtub with a mattress. Closets and walk-in showers that are deep inside the building can also offer good protection. Don't use elevators. You can get trapped inside if there's a power outage. Stay in your shelter until you're sure the tornado threat is over. If you can, listen for updates from the National Weather Service, local radio, or TV. Multiple tornadoes can hit the same area, so it might not be safe to leave even after one has passed. When you do leave your shelter, be very careful. There could be flooding, debris, collapsing buildings, and blocked roads. Stay away from fallen power lines and puddles with wires in them, and don't use matches or lighters in case of gas leaks. Stay away from damaged buildings as they could collapse at any time. Being in a car during a tornado isn't much safer than being out in the open or in a parking lot. Many people get injured trying to drive away from storms. Tornadoes can produce hailstones the size of softballs and can easily smash a windshield. If you find yourself outside when a tornado hits, try to get inside any building you can find. If that's not possible, get as low as you can. Even a ditch or culvert can be safer than your vehicle.
If you walk through this small stone doorway in Hierapolis, Turkey, you might never come back alive. Back in ancient times, people thought it was some sort of portal to the underworld. Romans would go in carrying perfectly healthy bulls, but after a few minutes, they would watch these animals collapse as if hit by some mysterious force. But what's even weirder is that nothing happened to people. They could walk in and out just fine. Now, recent studies might have an answer for these eerie happenings, and it all has to do with people's heights. The gate, known as Plutonium, named after Pluto, the deity of the underworld, is a stone doorway leading to a small 32-square-foot cave. But the real danger is what is going on beneath it. Hierapolis is a super active geological area, and there's a big crack under the city that constantly emits volcanic carbon dioxide, which comes up as a visible mist. During the day, the sun dissipates the gas. At night, the gas forms some kind of a carbon dioxide lake on the sheltered arena floor. At dawn, you need to get out of there before it's too late. This whole place can turn particularly life-threatening right before the sun rises, when the carbon dioxide concentration, about 15 inches above the arena floor, reaches 35%. That means birds, bulls, and even humans can suffocate and pass away in just a couple of minutes. But there is a scientific reason that explains how Romans could get out of there unharmed. The carbon dioxide concentration drops quickly with height. So animals perished while their handlers, being taller and standing up, could walk out and breathe safely. Most people can't stay inside the Begarn fort after sunset. This 16th century fort, located about 146 miles from Delhi, is known as one of the most haunted places in India. During the day, the area is bustling with visitors who can walk through the main gate of this once grand fort city and check out the ruins of temples and palaces. But they will also see this big sign at the gate that dramatically warns everybody that all access is strictly forbidden after dark. That's probably because at night, according to locals, women can be heard screaming and crying in that place, along with the sounds of bangles breaking and strange music. Others have reported seeing shadowy figures and flashing lights among the ruins, or even smelling a strange perfume floating around. Yawata no Yabushirasu is one of Japan's most restricted forests, located in Ichikawa. The forest itself is a small area, covering just a little more than 40 square yards, and it is mostly a thick patch of mosu bamboo. Its location next to a parking lot and modern buildings makes it seem less intimidating, but don't be mistaken by its appearance. Since at least the 19th century, people have said that anyone who enters this forest is bound to disappear and never be seen again. So, as soon as you arrive, a sign near the forest tells you about its history and the curse believed to be linked to it. Some rumors suggest the creepy presence of an ancient samurai lord walking around. Other legends say that the forest hides a bottomless pit filled with poisonous gas. Whether these stories are true or not, today, the area is enclosed by stone walls, and entry is still strictly prohibited. In a valley called the Dark Entry Forest in Connecticut, you will find Dudleytown, but you definitely shouldn't go inside. Not only has the land been private property since the 1920s, but it is also known as one of the spookiest places on Earth. This place was first settled in the early 1740s, and many of the original settlers were from the Dudley family. That's why it's called Dudleytown. There's a local rumor that the town's founders were descended from Edmund Dudley, an English nobleman who lost his life for treason. The legend says this curse followed the Dudley family all the way across the Atlantic to America, and their misfortune is said to be responsible for crop failures, mental problems, and several tragic incidents in the village. Again, it is all just rumors, since historians haven't found any real evidence to support these claims. Still, the pitch-black surroundings and the eerie Blair Witch Project vibe going on in that place fueled ghost stories in the 1980s. This led to many cases of vandalism in the following decade, and because of that, the landowners closed the area to the public. This old abandoned building used to be the fancy palace of King Farouk's family, who was the penultimate king of Egypt back in 1936. After his family members passed away, the palace was turned into a morgue. Locals say that today, the whole place is super creepy and off-limits. Some people have reported seeing light bulbs flicker and shadows move around, making strange noises. Once, a group of kids allegedly went inside and totally freaked out when they found all the doors had suddenly disappeared, leaving them in complete darkness. They had no choice but to start screaming for help. This Hawaiian island has been off-limits to people for over a century. It's called Ni'iau and is the smallest inhabited island in Hawaii, covering around 69.5 square miles. It has around 84 residents. The island doesn't have cell phone service, paved roads, or power lines, just solar panels for electricity. A single family has privately owned the island since 1864. when a Scottish farmer bought it for $10,000, which would be around $250,000 today. The island has stayed in the family, passing down to its descendants, the Robinsons. They have kept it private ever since, so access is highly restricted and basically by invitation only. The Erdstall tunnels are a network of about 2,000 mysterious underground passageways mainly found in Central Europe, especially in Austria and Bavaria. These tunnels are usually narrow and cramped, often just wide enough for one person to squeeze through at a time, and they are believed to date back to the Middle Ages, as far back as the 12th century. What's really puzzling about these tunnels is their purpose. Despite a lot of research, nobody really knows why they were built. There is a theory that they were used for storage, but since many of them are below the waterline and occasionally get filled with water, that doesn't seem very practical. These tunnels have very light, almost claustrophobic sections and sudden drops, which doesn't seem practical for other straightforward uses like escape routes, hiding places, or even spiritual purposes. To make things even more mysterious, there is a complete lack of artifacts, which makes it even harder for researchers to figure out what these tunnels were really for. Since 2019, adventurous people can get arrested if they try to climb this rock. Uluru, also known as Ayers Rock, has been off-limits because it is now considered a sacred site for local communities. But the fact that it is also extremely dangerous probably played a big role in the decision to close it off to visitors. This rock is 1,142 feet high, which is about the height of an 80-story building. The climb to the summit can be very slippery, and high temperatures, which can hit 116 degrees Fahrenheit in the summer, have led to people passing away from dehydration and heat-related issues. Something even creepier happens at the top of the rock right after storms. When it rains, small tadpole-like crustaceans called shield shrimp hatch in temporary waterholes and rock pools on top of Uluru. These extraterrestrial-looking creatures are about 3 inches long, and they spread their super-resilient eggs everywhere. When enough summer rain comes, they hatch and go wild, feeding on microorganisms and bacteria in the water. How these strange creatures end up in the fleeting pools on top of Uluru is still unclear, but the most likely explanation is that their eggs might travel there with the wind.
Living on our beautiful planet might seem safe, but only until you start thinking of all those dangers lurking just around the corner or in the vast darkness of the cosmos. Let's see what may eventually lead to the end of planet Earth. With each new potential threat, it gets more and more terrifying. Consider yourself warned. First of all, let's talk about Hypercane. This natural disaster can get really extreme. A hypercane is a theoretical hurricane of unsurpassed power. It would occur if the ocean became overheated as a result of climate change, or a massive volcanic eruption could trigger it. In any case, these conditions would create a hurricane, which, unlike regular hurricanes, would stretch way beyond the lower stratosphere. The speed of such a storm would reach 500 miles per hour. The pressure inside the hypercane would be so low that it wouldn't let it wear out as quickly as other hurricanes. The hypercane could last for weeks on end. But the worst thing? It would likely damage or even destroy part of Earth's ozone layer, and the hole could be the size of the entire North American continent. Then we've got super destructive tornadoes. A tornado is a violently rotating column of air. It usually extends from a thunderstorm and is in contact with the ground. Inside a thundercloud, warm, humid air rises upward, and cool air falls down along with rain or hail. Such conditions can lead to the appearance of spinning air currents inside the cloud. Interestingly, these air currents start out horizontal, but at one point they can become vertical and drop down from the cloud, becoming a tornado. Some tornadoes are narrow, rope-like swirls, but others turn into wild funnels. Tornadoes are ranked with the help of the enhanced Fujita scale. A weak tornado normally lasts for a few minutes and doesn't move faster than 100 miles per hour. The next level is a strong tornado. Such whirlwinds can last for 20 minutes or so and have winds of up to 200 miles per hour. And then we can also have violent tornadoes. Those can last for more than an hour and move at a speed of between 200 and 300 miles per hour. On average, around 1,000 tornadoes occur in the USA every year. There's even a region that got named Tornado Alley. It's a 10-state area in the Midwest, but tornadoes can happen in any state. One of the most destructive natural disasters was the tri-state tornado in the USA. It was the world's longest-lasting single tornado that traveled 220 miles through Missouri, Illinois, and Indiana. At the same time, the average tornado's path is usually no longer than 5 miles. But what if one day, a tornado much bigger and way more powerful than any we've experienced before swiped through countries and continents? It would leave behind total destruction and devastation. And how about a supercell thunderstorm? It's the least common type of thunderstorm, but it's the most dangerous. It's likely to cause severe weather, damaging winds, very large hail, and even violent tornadoes. What makes supercells unique is a deep and persistent rotating updraft called a mesocyclone. Supercells can potentially last for hours and cause great havoc. An asteroid impact could end all forms of life on Earth too. If a space wanderer was large enough, it could cause widespread devastation, like it happened with the 9-mile-wide asteroid from 66 million years ago. It's rumored to have destroyed 3/4 of the planet's plant and animal species, including dinosaurs. Depending on the asteroid's size and the speed of its approach, the impact could lead to massive fires, tsunamis, and the eternal winter effect. It happens when the debris ejected into the atmosphere blocks sunlight and disrupts the global climate. Luckily, we'd probably notice such a large asteroid coming close to our planet with the help of our equipment long before the collision and would have enough time to get rid of this threat. It would be our very own sun that would bring our world to an end. Our star is a gigantic, constantly changing ball of molten gases. Every once in a while, it spews out bursts of energy, solar flares. They often go hand in hand with something called coronal mass ejections. Those are giant bubbles of ionized gas that can accelerate to incredible speeds. The most powerful volcanic eruptions pale in comparison to solar flares that release 10 million times more energy. Within a few minutes, one solar flare can give out billions of tons of charged particles. Solar flares are also insanely hot, with the temperatures reaching several million degrees Fahrenheit. Astronomers believe that such bursts of solar radiation happen when the sun's magnetic field gets twisted in some regions. At one moment, all the pent-up energy is released. The star sends out light and particles, mostly electrons and protons. Most solar flares last for minutes, but some continue for hours. Scientists classify solar flares depending on how brightly they shine in X-rays. You aren't likely to notice the tiniest flares if you don't have special equipment. Medium solar flares lead to fleeting radio blackouts at the poles, but nothing too serious. It's X-class flares people should worry about. They cause the strongest and longest-lasting solar storms. Now, if you had gamma-ray vision, you'd be able to see immensely bright flashes. They occur every day, outshine everything around you, and then disappear again. Those flashes are gamma-ray bursts. One of them could wipe out Earth's atmosphere. The flash that might ruin our planet would most probably be born in a faraway galaxy during a merge of two collapsing stars. It would be immensely powerful and super bright. Still 1,000 light-years from Earth, it'd already shine as bright as the sun. Our planet's atmosphere would try to protect us, but its natural shield wouldn't last. The radiation would be so powerful that it would literally cook the atmosphere. It would create nitrogen oxides that would destroy the ozone layer. Without this layer, ultraviolet rays coming from the sun would be hitting Earth's surface at full force. They would wipe out tiny plankton in the ocean. But these plankton produce from 50 to 70% of all oxygen in the world. So, with their disappearance, there would be a severe lack of oxygen, which would lead to the disappearance of life on the planet. In the end, the heat and ultraviolet light coming from the sun would turn the planet into a huge chunk of rock. And what if we came across a wandering black hole? You might know that a black hole is a region in space where gravity is so powerful that not even light can escape its clutches. Luckily, the nearest to us black hole is 1,500 light-years away. It seems that we have nothing to worry about until we learn about wandering black holes. Now, things definitely get way creepier. If such a black hole entered the solar system, Earth would be doomed. We wouldn't stand a chance against this space monster. In 2020, 13 wandering black holes were spotted not so far away from our planet. But not far away in space terms means around 1 billion light years away, so we've got some time left. Plus, the possibility of such a disaster is very, very low. One day, a rogue planet might push Earth out of the habitable zone and into an extreme orbit farther from the Sun. Then, the climate all over the planet would start getting colder and colder. Don't forget that the farther our planet is from the Sun, the weaker the star's gravitational pull on our planet is. In the end, our beautiful Earth would get too far away from its main source of light and heat. It would turn into a lifeless piece of rock covered with a thick layer of ice. Or the Sun might expand and turn into a red giant. If it happened, it would change the entire habitable zone of our solar system. The disaster would start with our star running out of hydrogen in its core. This would trigger a chain of reactions, which would eventually lead to the core of the Sun heating up and getting denser. As a result, the Sun would get way larger than it is now. During this transformation, the Sun would swallow Venus, Mercury, and Earth.
It was the beginning of the 20th century, and two rivals, Robert Scott and Roald Amundsen, set on their expeditions to become the first people in history to reach the South Pole. The race wasn't easy, and it ended tragically for Scott. Amundsen has won and set his tent on the pole before his rivals. A member of Scott's expedition known as Terra Nova, British geologist Thomas Griffith Taylor, not only survived the harsh conditions, but also made an unexpected discovery. He found a waterfall of what appeared to be blood at the rocky base of the glacier, which now has his name, in 1911. It took scientists more than a century to figure out what is behind the eerie coloring. A team of American scientists journeyed to Taylor Glacier with powerful electron microscopes to analyze its contents. Previous studies had scratched the surface of the Crimson Enigma, but no one had previously done a full-scale analysis of its mineralogical makeup. These researchers unleashed a whole arsenal of analytical equipment and spotted little iron-rich nanospheres. These teeny-tiny particles, 1/100th the size of human red blood cells, originate from ancient microbes. They flourish abundantly in the meltwaters of Taylor Glacier. These nanospheres are jam-packed with iron, silicon, calcium, aluminum, and sodium, forming a unique composition that paints the subglacial water a vivid shade of red. These nanospheres don't have the usual crystalline structure found in minerals, which is why previous detection methods failed to spot them. Taylor Glacier's icy depths harbor an ancient microbial community that has thrived in isolation for thousands or possibly even millions of years. This discovery could help us in the search for life outside of Earth. Dr. Ken Levy, a research scientist at Johns Hopkins University, has some impressive expertise in planetary materials and the analysis of Martian samples. He decided to find out what would happen if a Mars rover landed in Antarctica. Could it figure out what makes bloodfalls so mesmerizingly red? So, researchers treated bloodfalls as a simulated Martian landing site. They used techniques inspired by the rovers exploring the red planet. The samples they collected were sent to Johns Hopkins processing facilities. There, Livy unleashed the power of transmission electron microscopy and revealed the enigmatic nanospheres. He made the conclusion that our current methods of analyzing other planets' surfaces with rovers fall short. They can't unravel the true nature of environmental materials, especially on chilly planets like Mars. These materials might be super tiny and non-crystalline, throwing off our detection methods. To truly grasp the essence of rocky planets, we'll need transmission electron microscopes. Strapping one onto a Mars rover isn't feasible yet, but it could mean a start of a new era in space exploration. Have you ever seen a waterfall on fire? Every February, when the stars align just right, Horsetail Fall in Yosemite National Park gets a sensational makeover. As the sun sets, its rays hit the waterfall at the perfect angle, transforming it into a blazing display of vibrant orange and red hues. We don't know exactly who and when discovered this natural miracle. The original valley dwellers may have known about it, but they kept it to themselves. It wasn't until 1973 that photographer Galen Rowell captured the first known photo of the waterfall, bringing it into the limelight. Since then, the firefall has become a global sensation, spreading like wildfire on social media and drawing crowds from far and wide. This magnificent cascade draws hundreds of spectators every year, but they can only see the show under certain conditions. First things first, Horsetail Fall needs a flowing stream. If there's not enough snowpack in February, the waterfall won't have enough water to create the magic. The temperatures must be warm enough to melt the snowpack during the day. If it's too chilly, the snow will stay frozen, and the fiery spectacle won't ignite. Second, we need a clear western sky at sunset. Those sunbeams need a straight path to hit Horsetail Fall and make it come alive. And since the weather in Yosemite is ever-changing, clouds can magically clear up just in time for the show. If all the conditions are just right, you'll witness the Yosemite firefall in all its glory for about 10 minutes. The mystery of the sailing stones in California's Death Valley National Park has puzzled scientists for years. Heavy stones seem to have a mind of their own and move across Racetrack Playa, a dried-up lake bed. They leave behind a trail on the cracked mud. There were all kinds of theories to explain this phenomenon, from magnetic fields or dust devils, which are strong whirlwinds, to mischievous pranksters. No one has actually witnessed these rocks in action, which only added to the mystery. In 2006, a NASA scientist named Ralph Lorenz entered the scene. He was studying weather conditions on other planets, but he couldn't resist the allure of Death Valley and those elusive sailing stones. He had an eureka moment while tinkering at his kitchen table with a Tupperware container. Lorenz filled the container with water, leaving a small rock poking out, and chucked it in the freezer. Then he placed this icy construction in a big tray of water with sand at the bottom and gently blew on it. The rock began to glide across the water, leaving a trail in the sand. Lorenz had been studying how ice can make big rocks float and move along tidal beaches in the Arctic Sea. Applying this knowledge, he and his research team figured out that, under certain winter conditions in Death Valley, enough water and ice could form to make the rocks float across Racetrack Playa in a light breeze. And as they glided, they left their mark in the muddy terrain. The River of Five Colors, Cano Cristales in Colombia, has the unofficial title of the most beautiful river in the world. For most of the year, it looks like any other regular river. The real magic happens between the wet and dry seasons, when the water level is just perfect. This unique river floor is lined with a special plant, and when the conditions are right, it bursts into a dazzling display of colors. Think vibrant reds, stunning yellows, and lush greens, all mingling with the blue water. It's like stepping into a living rainbow with 1,000 shades in between. This phenomenal display only lasts for a few weeks, from September through November. During Colombia's wet season, the river flows too fast and deep, covering up the river floor and denying the plant the sunlight it needs to turn red. And in the dry season, there's simply not enough water to support the vibrant life in the river. So you have to catch it at just the right time. The reason behind Maldivian beaches glowing in the dark at night isn't a mystery, but it doesn't make them any less impressive. It happens thanks to the bioluminescent plankton. These tiny creatures are like little underwater disco balls, emitting a cool blue glow when they are agitated or on the move. Imagine walking along the shoreline and leaving behind glowing footprints. You can even take a night swim amongst these magical plankton. Researchers have discovered that their bioluminescence is actually a clever defense mechanism against predators. When these microorganisms flash their little blue lights, it disorients and surprises their attackers. The plankton produces this light using a chemical called luciferin. These enchanting plankton can appear at any time of the year. The best chances of seeing them in all their glowing glory are from June to December. During this period, there's a higher volume of plankton in the seas of the Maldives, creating the perfect conditions for a luminous show after the sun sets and the night sky takes over. You'll only witness the magic of bioluminescent plankton when tidal currents bring them close to the shore in large numbers. It's hard to predict exactly when this spectacular show will happen, So make sure to do your research and prepare to take photos with a high ISO to capture it, exactly like it looks in travel catalogs.
You're dozing off in your window seat on a plane. It's getting dark since it's almost 11 p.m. Suddenly, something wakes you up. You glance out of the window and see a really strange phenomenon, something that creeps you out. There are bright red, huge flashes illuminating the sky at a distance. They resemble some nightmarish jellyfish. Those are sprites, also called red sprites due to their color. They're also known as cloud-to-space lightning. These varied visual shapes flickering in the night sky are large-scale electric discharges, which is a clever word for a lightning strike. They occur high above thunderstorm clouds at altitudes of 30 to 56 miles. That's why you can see them so well from your plane window. The coolest thing about sprites is that they're positively charged lightning. This is a very rare type that makes up a mere 5% of all lightning strikes. People first spotted this phenomenon in 1886, and it was first photographed in 1989. In 2018, the legendary Niagara Falls, located at the border between New York State and Ontario, Canada, managed to surprise everyone. Tourists who came to admire the roaring waters found the falls frozen. Well, the waterfalls weren't frozen per se. This is impossible for a mass of flowing water that huge. But microscopic water droplets, as well as the mist, formed a crust of ice over the rushing water. It created an illusion that Niagara Falls was frozen all over. In reality, the water kept flowing beneath the ice. Imagine ponds filled with ice-cold water and covered with ice. Easy, huh? And now picture dozens of alligator snouts that are poking out of the ponds, still and frozen in ice. That's what you'd seen if you had visited the swamps of North Carolina at the beginning of 2018. Despite this terrifying picture, the animals were very much alive. That was a very special crocodile way to survive abnormally cold weather. Since their nostrils were above water, the animals could breathe. Meanwhile, their bodies were in a hibernation-like state. It allowed the animals to conserve energy and stay warm. In the winter of 2018, the inhabitants of the Sahara Desert, one of the driest and hottest places on the planet, woke up to discover a thick layer of snow covering the sand. In some places, its depth reached a staggering 15 inches. Meteorologists had an explanation for this exciting phenomenon. They said that cold pools of air combined with the precipitation of the most recent storm resulted in snowfall instead of rain. It happened in June 2009. People in some areas in Japan left their homes after a heavy downpour, only to find fish, frogs, and tadpoles everywhere. Fields, roads, lawns, and house roofs were littered with these creatures. One man even found 13 carp on and around his truck. No one knows for sure where this bizarre rain came from, but the most popular theory is that a powerful water spout picked up the animals. Then it carried them through the upper atmosphere and dropped them on the unsuspecting people below. In Australia, it sometimes rains spiders. That's because these creatures can balloon. It's a highly unusual way of traveling. A spider climbs to the very top of a tall tree or shrub, and then it spins several strands of silk, which then help the spider to be carried away by the wind. It's not easy to spot ballooning spiders, but sometimes when the weather is especially damp and unpleasant, mass ballooning occurs. Millions of spiders set off on a journey to find another place with better conditions. It may look as if it's snowing outside, but no. Those are spiders drifting down to the ground. The world's longest lightning storms happen in Venezuela and can last for 9 hours per day. The heart of the storm is over Lake Maracaibo, and the clouds tower way higher than your regular thunderstorm clouds. This natural phenomenon, also known as Catatumbo lightning, occurs during 140 to 160 nights a year and can produce up to 28 lightning strikes per minute. You've probably heard how they say that lightning doesn't strike twice in the same place. Well, Catatumbo lightning seems not to know about this rule. At least, it doesn't prevent storm clouds from gathering in the very same place year after year. volcanic tornadoes are possibly one of the most terrifying natural phenomena. When a volcano erupts, it spews red-hot rock and ash high into the atmosphere. And solid lava pieces and hot gases travel down the volcano's slope. When this flow is moving down, some of the trapped gases begin to rise and spin at the same time. They get squeezed by the surrounding air, which makes them spin faster and faster. That's how a volcanic tornado gets born. Luckily, this phenomenon has a very short lifespan. Even though the island of Newfoundland in Canada can't be called the warmest place on Earth, it's still not that cold. But imagine having to shovel snow in front of your house just several days before your summer vacation. Well, that's exactly what happened on the island in June 2018. A cold storm that came from the coast of Newfoundland covered several regions of the islands with a 2-inch layer of snow. On top of that, the temperature broke all the records as well. During a Newfoundland summer, it's about 66 degrees on average, and 90 degrees on a very hot day. But that infamous June impressed people with only 37 degrees Fahrenheit in the morning. Brrr! Morning glory clouds are extremely rare. They look like massive tubes stretching across the sky. They can snake for more than 600 miles, sitting relatively low. Most researchers agree that these clouds appear when an updraft squeezes through the cloud. This creates the signature rolling appearance. The cool air at the back of the cloud makes it sink downward. The best but not the only place to see the morning glory is Australia's Gulf of Carpentaria. If you decide to travel there to see these clouds, choose a period from late September to early November. On March 19, 2018, the inhabitants of Alabama saw huge chunks of ice falling from the sky. It was the infamous hailstorm of Alabama which caused millions of dollars worth of damage. After the hailstorm, the place looked ruined. Broken shop windows, smashed car windshields, broken billboards, and holes in the roofs. But what made researchers really excited was a hailstone found near the town of Cullman, Alabama. This softball-sized monster was more than 5 inches across, setting a new state record. In 2012, the sky over Dorset, England turned first ominously dark, then yellow. After that, blue gelatinous balls started to fall to the ground. A local man was walking to his garage when he spotted something unusually bright among whitish hailstones. When researchers examined this jelly rain, they found out that the balls were made of the substance used in diapers or potting soil. It's used to absorb liquid. It's still unclear whether the balls fell from the sky or maybe the melting ice made a few already existing crystals expand in the blink of an eye. In March 2018, people in northern Nevada could see the rarest and most bizarre cloud ever, a horseshoe cloud. It sure looks bizarre and kinda scary, but meteorologists know that this interestingly shaped vortex happens when a flat cloud travels over a column of warm, rising air. This air creates the shape and adds some spin to the cloud's movements. Such clouds are very fleeting and usually last for only several minutes. Cylindrical snow donuts occur when a wind gust decides to play snowballs. It starts to roll some snow across a snowy area. If it was a real snowball, it would eventually become too heavy for the wind to move. But the center of a snow donut is hollowed out. This happens because its inner layer is too thin and gets blown away when the donut is formed. This makes it lighter than a regular snowball. That's why it also rolls further. Unfortunately, you can't just go and find snow donuts. They're rare because they appear in very precise conditions.
So in Westbrook, Maine, people saw an enormous ice disk in January 2019. This disk was like a wintry carousel. It was spinning away in the Penobscot River. Residents called it everything from an icy lazy Susan to a frozen spinning wheel. It was estimated to be around 300 feet wide, which made it one of the biggest ice disks ever seen. Weirdly, the spinning ice disk notion isn't new. They've shown up in places like Russia and Washington before. They were almost always a perfect circle. So why do they happen? Well, some scientists in 1997 thought it was because river water created a whirlpool effect around a chunk of ice. smoothing it out to be perfectly circular. Yet, in 2016, other scientists claimed that river currents helped these disks get started, but temperature changes kept them twirling. Warmer water makes the ice melt and sink, creating a vortex that keeps the disk spinning. The warmer the water, the faster it spins. Ever heard of the Hestilin lights of Norway? They aren't the same as northern lights. Think of these lights as glowing balls. They have been seen since at least the 1930s. These luminous wonders show up in all sorts of colors and shapes. Sometimes they flicker, and other times they just chill in the air. The Hestilin lights can show up 10 to 20 times a week. They appear both during the day and at night. They can last for just a few seconds or hover for over an hour. Interestingly, nobody has a clue about what exactly they are. The efforts to understand these lights include Project Hestilin, started in 1983, and later projects like the Triangle Project. Despite ongoing research, there's no consensus on the origin of the lights. Some suggested explanations include misperception of celestial bodies, aircraft, or mirages. One theory ties the lights to airborne dust from mining, while another mentions plasma, formed by ionized air and dust during radon decay. Okay. Ringing rocks is a cool geological thing you probably didn't know about, and it's our next stop on the Mysterious Natural Phenomena Tour. You can find them in Bucks County in the U.S. If you give these rocks a hit with a hammer or another rock, they start ringing. Scientists have been studying them, but the mystery remains. There are different hypotheses about this one too. Things like the size and shape of the boulders and how they're stacked can affect the sounds they make. But that alone doesn't give them the ability to ring. Even though the sound is often described as metallic, it's likely because of the rock's density and internal stress, not just its iron content. A scientific experiment from the 1960s suggested that the ringing ability came from some internal stress, not external weathering. The live rocks, found in the middle of boulder fields, showed expansion or relaxation after being cut, indicating internal elastic stresses. A slow weathering rate in dry fields could cause these stresses. The relic stress theory suggests that these boulders act like guitar strings. A de-stressed boulder gives a dull thud, but a stressed one resonates at different frequencies. The boulders can still ring when removed from their fields, leading to myths about stealing them. Most fields are now cleared of smaller ringers, and breaking large boulders stops the ringing. Large equipment is needed to move the remaining small ringers, weighing over a ton. Now let's talk about the Naga fireballs. They only show up along the Mekong River in Asia. These picky fireballs hang out in just a 155-mile stretch of the river. The reddish glowing balls rise naturally from the water into the air. Their scope ranges from small particles to the size of a basketball. The reported number of fireballs varies, from tens to thousands per night. They can be spotted all year round, but they seem to go wild during the full moon in late autumn. Why? Well, that's just another one of their little mysteries. Some have tried to explain the phenomenon scientifically. One theory suggests that flammable phosphine gas from the marshy environment could be the cause. However, skeptics argue that spontaneous ignition isn't likely to be the reason. Another scientific explanation involves free-floating plasma orbs created when surface electricity is discharged into a solution. Still, these typically occur in controlled settings during experiments, and not naturally. We can carry on with ball lightning. It's a super rare thing, a glowing ball that shows up in the air. It likes to make an appearance close to the ground during thunderstorms, hanging out with regular lightning. It can be red, orange, yellow, white, or blue, and it's often accompanied by a hissing sound and a funky smell. This flashy sphere of light is a quick show. It lasts just a few seconds, zooming around, and then poof, it's gone, sometimes quietly, sometimes with a little pop. Ball lightning might seem like a troublemaker, but it's usually harmless. Sure, it's been known to burn or melt stuff on occasion, but it's not out to get us. Scientists aren't entirely sure why it happens or how it's related to regular lightning. People have been tossing around ideas like weird air or gas behavior, high-density plasma stuff, or even a vortex of glowing gases. Even microwave radiation trapped in a plasma bubble is on the list. But don't get it confused with bead lightning. That's a different one, more like a string of beads. And it happens when a bolt of lightning sticks around for a good chunk of a second. Shh. We're now at the Mapimi Silent Zone. It's this spot near this place in Mexico. The story goes that in this desert patch, you can't pick up any radio signals or talk to anyone. In July 1970, a rocket from Utah went off course and landed here. It was carrying some sort of cobalt. Authorities had to haul away tons of soil from the crash site. Now, thanks to the cleanup, the silent zone is wrapped up in myths. People talk about weird magnetic stuff messing with radios and about plants and critters going through mutations. Well, locals go with it, boosting tourism in the region. Alright, we can now talk a bit about the Sun. Well, it's not just a big ball of fire. It's got an outer layer called the corona. Think of it as an invisible sun jacket made of gases. You usually can't see it because the sun is super bright. But there's a trick. During a total solar eclipse, when the moon slides between us and the sun, the corona shows up, all glowing and white. The corona is scorching hot, even hotter than the sun's surface, which is kinda weird. Scientists are on a mission to crack this heat mystery. They found something called heat bombs shooting from the sun into the corona, exploding and warming things up even more. But that might be just one piece of the puzzle. You see, the sun's surface is like a playground covered in magnetic fields. These magnetic fields create cool shapes on the sun, like loops and streamers. Special telescopes help us see these cool patterns up close. The corona stretches way out into space, and from there, it sends out the solar wind that moves through our solar system. Its particles are so speedy that they escape the sun's gravity. So, there's this cool spot called Kuala Sangalore Beach that you can only check out when the tide is low. The timing changes every day, and you can't get there when the tide is high. Most of the time, it's hiding under the sea, not even on the map. But when the tide's just right, bam, it pops up. Kind of like Malaysia's own version of Salar de Uyuni. People call it the mirror of the sky because when it's not underwater, it turns into a giant reflection of the sky. An awesome spot for cool Instapics. Besides being a sweet travel spot, it's also home to a bunch of marine life, like sea and baby clams that live all over the sandy shores.
On September 16th of 2023, without warning, the Earth began to hum. A low, strange vibration reverberated through the crust. This set off seismic alarms all across the globe. For 9 days straight, the planet was pulsing with this horrifying rhythm, and scientists had no idea what was going on. Meanwhile, the total disaster was happening in Greenland. It wasn't an earthquake. They knew that much. They could tell it by the rhythm. Since we all live on giant tectonic plates, they constantly move and slide on magma like icebergs on water. Sometimes as they move, they can rub against each other or collide or break. In any case, all this causes an incredible release of energy that sends shockwaves through the ground. That's when we feel the ground literally shaking, and it's what we call an earthquake. These vibrations we feel are called seismic waves. Seismometers pick them up as pings or rumbles. In a typical earthquake, they create a bunch of different frequencies. It's a crazy chaotic mix of low and high frequencies, like smashing every piano key. What was weird about the Greenland event is that the signals weren't like that at all. It was a steady, single-frequency vibration, as if some ancient machine was stirring beneath the Earth. It's like one piano key being struck over and over, creating a doom-like, repetitive sound. Turns out, what they were hearing wasn't the noise of tectonic plates going wild. It was a phenomenon seismologists had never seen before. The days passed, and the mysterious noise just kept going. The vibrations repeated every 90 seconds, echoing around the world. The hunt for answers was growing more desperate. Seismologists had no idea what they were dealing with. They had to gather a huge international team of 68 people from 15 countries. All these scientists were gathering seismic data, satellite images, and doing some advanced math for several days, until they finally realized who the culprit was. Water. It all happened in a remote, desolate region of East Greenland. This place is full of fjords, narrow inlets of the sea between high cliffs, kinda like deep water-filled valleys surrounded by towering rocky sides. In this area, surrounded by jagged peaks and icy waters, the air was still. The landscape seemingly frozen in time. Nothing here changed much for years. Until one day, a colossal landslide has unfolded in the Dixon Fjord. One of those steep mountainsides towering over the fjord at almost 4,000 feet high collapsed in a massive landslide. Picture a huge chunk of this mountain crumbling and crashing down into the fjord below. This sent a deluge of rock and ice crashing into the water. The impact was just apocalyptic, 882 million cubic feet of debris. That's enough ice and rock to fill 10,000 Olympic-sized swimming pools, or 10 Great Pyramids of Giza. And all this nightmare hurled into the water with such force that it kick-started a tsunami about 360 feet high, taller than the Statue of Liberty, into the air. What's crazy is that this incredibly powerful wave was trapped in the fjord by narrow cliffs, unable to escape. It's like water sloshing in a closed bathtub. For 9 days, the mega tsunami continued to churn through it. That's why we heard this endless hum. It was a rhythmic back and forth of the water slamming against the walls. The shock waves were rippling deep into Earth's crust, vibrations so strong that they were picked up by seismometers around the globe. This was a phenomenon so rare, so unprecedented, that it left scientists stunned. It turned out to be a perfect storm of elements. A glacier, weakened by years of warming, could no longer bear the weight of the mountain above. This collapse was inevitable, and the chaos literally shook the Earth to its core. And people often hang out in this area with cruise ships passing by. We're lucky that no lives were lost in the disaster. It was a close call though. A tourist ship stranded in the area just 2 days before narrowly escaped the tsunami's reach by pure luck. But it doesn't mean there were no losses. The waves destroyed a nearby Inuit site, which was there untouched for over 200 years. They also swept away the huts at a research station that were about 43 miles away. The vibrations traveled from Greenland to the South Pole in less than an hour. That just shows how dangerous events like this can be. And this isn't the only place where such catastrophes are happening. In the beautiful California community of Rancho Palos Verdes, the ground is shifting so quickly that it's tearing homes apart. The land there has always been kinda unstable. It has some unique geology. It's built on soft, clay-rich soil and sits on a geological fault line, which makes it prone to landslides. This means that this land is prone to slow, natural shifting over many years, even when no crazy weather is happening. It's been like this for decades, but usually it's slow and pretty manageable, like about a foot a year. Imagine a tree that you played with as a kid moving 20 feet to the left as you grow up. For decades, residents adapted. They built their homes on adjustable beams. This helped the houses to move with the land, and that strategy worked well until now. Recently, things have been getting much worse in the community. Now, the land is moving by a foot in a single week. That would be like if the same tree moved almost 960 feet since you were a child. The past 2 years have also caused some heavy rains, and the weather has been getting worse. This increased water content in the soil. The land became heavier and more prone to rapid movement. Now, this once idyllic seaside escape turned into a disaster zone. Cracks have appeared in closets, gardens, and roads, growing larger with each passing day. Streets that were once smooth are now buckled and twisted, with roads turning into a crazy theme park. Houses that once stood firm are being ripped from their foundations, some of them split in half. One of the houses had its front door 8 feet off the ground. Entire neighborhoods have been plunged into chaos. Utility companies had to switch off gas and electricity indefinitely to prevent potential disasters. The hardest hit is the coastal neighborhood of Portuguese Bend, where residents are living on the edge, literally. It always had amazing ocean views and cool sea breezes, with horses and peacocks still wandering the tree-lined streets. But now, it's like an earthquake hit. Only this time, the Earth isn't stopping. For many, this place feels like paradise, if only the land would stop shifting beneath their feet. So the locals don't give up. Some of them had to leave, but many are determined to stay and fight, despite the destruction. But they still have to pour in hundreds of thousands of dollars to save their properties. People have installed generators to keep the lights on and set up sewer systems and pumps to drain the groundwater causing the landslides. Some say that the only way for these neighborhoods to survive might be to go completely off-grid, installing power walls to store energy and stuff like that. People are trying their best to run the sewer system off generators. They hope that they could get rid of this water in the soil that's causing these hellish landslides in the first place. They're determined to fight, but they will need help and support from the government to fight this disaster. Landslides are actually more common across the US than many might think. And new maps and data show that tons of people in the country might be in danger. Scientists managed to create the first very detailed, very cool map that shows where these landslides might happen, county by county. It's based on a lot of data and the history of 1 million previous landslides. They say that nearly 40% of the United States is at risk of experiencing landslide activity, which could lead to some insane catastrophes in certain areas. Luckily, now both residents and engineers can keep this in mind. But all this shows how vulnerable we are to natural disasters, and how we should always stay alerted.
The ground shakes beneath you. The pictures rattle on the walls. You hear a rumble off in the distance. Then, boom, a deafening explosion. The shockwave blasts through the windows and sets off car alarms. You duck under the dining table for cover, but then you remember you live not far from a supervolcano in the middle of a tropical jungle. So, staying in one place isn't a good idea. The shaking finally halts. You take this chance to peek outside and see a giant cloud of smoke covering the sky. It's lunchtime, but you wouldn't know it. The sun is completely veiled and darkness falls. The power's out in the whole city. In this darkness, you see red molten lava shooting from the sky and spilling on the rim. You run outside along with dozens of your neighbors. Your priority right now, find safe shelter and fast. You think about taking the car, but with everyone running on the road, that's a no-go. So you run on foot where the crowd is going. Supervolcanoes are in a league of their own when it comes to natural disasters. Surprisingly, it's not all about size or height. A volcano is dubbed super if it erupts more than 240 cubic miles of magma. That's more than enough to overfill Lake Erie. It must also have a history of erupting and a magnitude of 8 on the Volcanic Explosivity Index. The largest active volcano on Earth is Hawaii's Mauna Loa. It's so big, it would cover the entire state of Rhode Island plus some. And next time you see a commercial plane flying high in the sky, remember that 30,000-some-foot altitude is about as tall as Mauna Loa is from base to summit. It's technically taller than Everest when you measure it like that, yet it's not considered a supervolcano. So you're running along the dark road not knowing and barely seeing where to go. Then, all of a sudden, a massive flaming boulder smashes through the bridge in front of you. You and everyone else are now stranded on the side of the volcano as it's getting more chaotic each second. Most of the crowd disperses, finding their own ways to safety. You remember there's a way to the other side not many people know about, but you'll have to cross a raging river through the dense jungle. You calm what's left of the crowd, and everyone follows you to your secret getaway. You finally get out of the city limits and head into the jungle. With the sky already dark, the tall trees and thick leaves make it almost pitch black. Everyone gets out their phone flashlights to navigate through the dark path. You all need to stick together and make sure nobody gets lost. Suddenly, fiery rocks strike the trees not far from you. Everyone jolts and tries to rush ahead, but nowhere is safe when it's raining scalding fire all around. You and your group have to pick up the pace or else. Imagine a typical avalanche or mudslide, very dangerous situations on their own. Now, imagine an avalanche of lava rocks and lava sliding down a mountain instead of mud. That's what's making its way towards you right now. More and more people catch up with your group and bring news that the entire neighborhood is submerged in lava. It's traveling quicker than you thought. You can never really predict how fast a lava flow will be until you see it. It all depends on how thick it is and how steep the mountain slope. Lava can move slowly at about 20 feet a minute, a fraction of the average person's walking speed. Or it can flow as fast as 30 miles per hour, which even the fastest person on Earth can't outrun. But the lava isn't even the most dangerous problem. If you didn't have protection, the gases spewing from the eruption would fill your lungs, and those spread faster and further than the lava flow. Your eyes and throat would be itchy. You'd get a headache, dizziness, increased heart rate, difficulty breathing. The worst would be passing out from the lack of oxygen. Luckily, everyone managed to grab their gas masks before leaving their homes. You're now entering the treacherous terrain of the jungle and the danger zone. Everyone's phone batteries are giving out one by one, so your vision is even more limited. The terrain is tougher and you can't hear any sounds from the river. At this point, you're not even sure if you're going the right way. But your instincts tell you the deeper you go, the safer you'll be. The path is muddy, and the vines are hindering everyone's movements. That's when you hear something big running through the jungle. It's coming up on you fast. You can't see a thing until it's right up on you. A bear! And there goes a rhino. Wild cats, domestic cats, dogs, different creatures of all sizes and species. They all come running through the jungle right past you. You and your fellow humans aren't the only ones fleeing from the eruption. The rumbling is still going on. Before you know it, a shower of fire rocks strikes right behind you and ignites parts of the jungle. There's no going back. Everyone picks up and runs for it. You hear thunder in the distance. A flash of lightning lights up the dark sky. You think, finally, some rain to wash away this fiery nightmare. But that's not a regular storm brewing. These giant smoke clouds can mimic a thunderstorm under similar conditions. Your luck finally pays off. You hear the river straight ahead. You reach the bank and have to hop on some stones to get to the other side. You almost slip when someone from the group catches you just in time. Whew, that was too close. Not far down the river is a large waterfall leading straight to a shallow lake with sharp rocks at the bottom. The ash from the lava falls like snow, covering most of the trees and landing on the river. Ash is one of the most dangerous things about volcanic eruptions. You're soaked to the bone, but it's a lot better than ash and smoke. And then the rest of the group follow. The next thing you know, the river starts steaming as lava meets the bank and runs into the water. You try your best to speed things up. The lava can heat this water up to dangerous levels, and there are still people slowly crossing the river on the slippery rocks. Luckily, you manage to get everyone across. Well, almost everyone. You turn around and see someone's leg got caught between two rocks. The lava continues to pour into the river. You can feel the heat of the steam. You rush back to this person and try to pull them out. Their leg won't budge. Someone else from the group comes to help, and you're finally able to pull them out in the nick of time. You and everyone else, now exhausted from your trek, keep going as far as possible. That's when you see the main road that connects you to the broken bridge. There are others on the road that got out safely, and even some cars filling up with survivors and heading fast out of the area. The volcano is still spewing lava, and the entire city is flooded with it. What was once your town now looks like a giant burning lake. Planes and helicopters can't fly because of the smoke and ash, so don't count on an air rescue. You're still at risk even though you're on safer ground, so it's still too early to celebrate. Everyone continues to move away from the city. The further, the better. The ground continues to shake, but this time it's even more intense than before. Supervolcanoes are powerful enough to cause many earthquakes. But it's a good thing you're out in the open, far from the buildings and debris in the city. Now, back to reality. Rest assured that a volcanic eruption of this intensity won't happen for a very long time, as in millions of years. Besides, thanks to warning systems and humanity's preparation for such an event, it's extremely rare for even a regular volcano to do as much damage as it could. So, don't scratch Yellowstone off your travel list just yet.
This is John. John seems to attract all kinds of bad weather and natural disasters wherever he goes. See for yourself. One day, John notices his dog is restless. The pooch keeps scratching the entrance door and wandering around the house. He even tries to hide in the corner, howling and barking. When some mugs start to clink in your cupboard, John realizes what it means. The noise is produced by foreshocks, mini earthquakes leading up to the main event. Earthquakes often happen in clusters. After a few weak quakes, a much bigger one is likely to be on the way. Sometime before the disaster strikes, people might notice bizarre blue lights. Some of them seem to be coming out of the ground. Others are hovering in the air. These are earthquake lights. They may appear days or mere seconds before the ground starts shaking. Now, John is walking along the ocean shore. Suddenly, he sees the water retreat from the beach. Really fast. Uh-oh. John, run away as quickly as you can and find some high ground. A tsunami is coming. And your life might depend on how fast you react. If John spots a bizarre and unexpected rise in sea level, it can be another sign of an approaching tsunami. This happens in 40% of cases. The incoming water is the first tsunami wave. The second one, way larger, will come in about 10 minutes. John can also notice seawater bubbling, swirling, and creating bizarre patterns. It's another sure sign a tsunami is near. John feels there's something strange about the sun. Through his special super dark sunglasses, he sees that there's some uneven flares around the star's contour. If these bizarre rays are accompanied by auroras all over the world, they're a sign of a solar storm. Such storms are usually caused by disturbances in the sun's magnetic field. In this case, the bursts of gas and radiation on the surface of the sun get so massive and powerful that they can even reach our planet. Luckily, solar storms aren't really dangerous for people, but they can mess with electricity and even cause blackouts. The sky over John's head is darkening and turning ominously green. Something hits him on the forehead. Ouch! He picks up the offending object. It's a hailstone, but it's not that cold outside, and it's not raining. Soon, he hears some noise. It's approaching rapidly and turns into a loud roar. It sounds as if a freight train is moving towards him, but it's not a train. It's a tornado. The funnel isn't visible behind a cloud of debris, but John can't mistake this rotating column of air for anything else. Are you on the road, John? Then get as far away from your car as you can. Fast! Find a ditch, lie down in it, and cover your head. Oh, you're inside? Then get away from the windows and hide underground if possible. And please, John, be very careful if you spot some conically shaped clouds. Those mean severe storms. And if you notice that such a cloud starts spinning around, immediately search for shelter. The cloud is transitioning into a tornado right in front of your eyes. On the bright side, John should only worry about warm conical clouds. Cold ones are totally harmless. The only problem is to figure out the temperature of the cloud he sees. Duh! Ah, look, John just spotted some weirdly shaped trees. They look like the letter J and grow on a slope. It means the ground under John's feet is likely to be unstable. If he keeps wandering around, it can cause a bad landslide. Square waves appear when two different wave patterns crash into each other. This phenomenon does look kinda awesome. No, don't go into the water, John. Keep watching it from the shore. Cross currents in that spot can easily pull even a skilled swimmer under the surface. John keeps walking along the shore. At one point, he sees wild, choppy waves carrying ocean debris and seaweed. This time, he stays out of the water. He knows it can be a sign of a strong rip current. It can carry a swimmer far away into the ocean. How about a walk in the park? John likes this idea. The sun is shining and the sky is so blue and beautiful. Suddenly, he spots a rapidly growing vertical cloud. At first, it looks bright white. But as it approaches, alarmingly fast, it becomes dense and inky. The sky is darkening. It's getting windy. That's when the guy notices that his hair stands on end. It's his cue that he's about to get hit by lightning. At this very moment, positive charges are rising through his body. They're reaching towards the negatively charged part of the storm. If he doesn't react fast, these charges will meet. There's nowhere to hide, so John should crouch down and try to make himself smaller than the objects around him. Oh no, John, don't lie down on the ground. It may be damp and thus a great conductor of electricity. There are other signs that scream danger during a lightning storm. John's palms may begin to sweat. He might hear bizarre crackling and buzzing sounds coming from metal objects nearby. His skin can start tingling. There might be a strange metallic taste in his mouth. Plus, John is likely to smell chlorine. That's how ozone smells. Electrical charges split the molecules of nitrogen and oxygen, which are the main gases making up the atmosphere, into separate atoms. When these atoms come together again, some of them produce molecules made up of 3 oxygen atoms. That's ozone. We can smell it during a thunderstorm because downdrafts bring this gas from high altitudes to your level. Some bugs can feel a storm coming. They get ready for a natural disaster by freezing. So, when John notices that insects around him look drowsy, he knows to get ready. Oh, and bees can predict heavy rainstorms. These critters begin to work much harder the day before it starts raining. While walking next to the river during a period of heavy rains, John hears a roaring sound. He feels paralyzed with fear. It's likely to be a flash flood moving in his direction. Indeed, he soon sees debris coming down with the flow. The water is rapidly changing its color, becoming muddier and darker. Flash floods are very, very dangerous. Take care of your safety immediately, John. Another day, John sees a spectacular wall cloud. It seems to be stretching for up to 5 miles. In the best case scenario, it's just a severe storm coming. But if the wall cloud begins to move in a circle, it's a sure sign of a tornado. John is walking across a snowfield in the mountains, listening to the sounds the ice under his feet makes. The noise is kinda hollow. Quickly check whether there are cracks around your footprints, John. If so, the chances are an avalanche is about to happen. Soon, John sees an avalanche moving in his direction. He does his best to get off the slope. In most cases, he could probably outrun it by heading downhill and then veering sideways, but not this time. He realizes he doesn't have enough time and heads for the nearest tree. If John keeps holding on to it really tightly, the avalanche might not pull him along. But if this doesn't work, he should try to swim up to the snow's surface while the avalanche is still moving. On a pretty nice summer evening, John notices leaves with soft stems droop all of a sudden. It might be because of an upcoming storm. Right before extreme weather arrives, the air usually becomes more humid. Leaves also get damp and heavy, and the wind easily flips them over. John lives in a pretty old house and is used to having cracks in the interior walls, but one day, he notices that some of them have widened, and look, there are a few new ones. It's an alarm bell. He lives in an area with loads of limestone, so new cracks can mean a sinkhole is about to open next to his house. John is hurrying home, trying not to waste time admiring shelf clouds. They look like something from a sci-fi movie. They form when warm and moist air gets caught in a thunderstorm updraft, and these ominous clouds most often mean a storm is coming.
Hey, ever heard of a fire rainbow? Yeah, me neither. How about a circumhorizontal arc? Didn't think so, but just so you know, they're one and the same thing. At first glance, it looks like a painting, or like a rainbow-colored splash in the sky. Despite the name, they have nothing in common with either fire or rain. This phenomenon happens on rare occasions when the sun shines through a particular type of ice cloud formation. The rainbow halos are just as unique. Again, a specific type of ice crystals in clouds needs to be present for the surface of the Earth to bend light from the sun into a perfect ring. The same thing can happen with moonlight. The only difference will be that moon halos are usually white and sun halos can be rainbow-colored. When visiting regions with high altitudes, you may be one of the lucky people to stumble upon penitentes. They're basically naturally formed ice spikes. For them to be formed, they need a really cold and elevated environment where the air is dry. The sunlight turns ice directly into vapor rather than melting it into water. And that's why these blades of snow and ice start to pop up on the surface of the Earth. As cute as they may be, they can end up as tall as 15 feet. Now, what happens when small individual droplets of lava meet the wind? Pele's hair, basically. Let me explain. The word Pele comes from an ancient Hawaiian symbol for volcanoes. Whenever the wind picks up little drops of lava, it stretches them into hair-like strands, similar to the process of glass wire creation. These delicate strands can stretch as far as 6 feet. On rare occasions, it can rain without any clouds. But does it really? Let's look at the science behind this rare phenomenon. It's sometimes called a sun shower, just because it looks like the rain is falling straight from the sun. Let's be clear though, there is no way rain can ever come down directly from a star. Rain clouds are at a bit of a distance from that specific location. With sun rays being angled, the clouds become out of sight. Add a little wind to blow the rain in your direction and ta-da! You get sun showers. Located in Bolivia is a place called Salar de Uyuni. It's the largest salt flat in the world. It's also the home of half of the world's lithium, which is a crucial component for making batteries. But what else is so special about this place? Well, whenever the rain season comes, it turns this piece of flat land into a perfectly reflective mirror lake. What comes to your mind when you hear about the Blood Falls? A horror movie? Well, they are merely a series of waterfalls located in one of the driest regions of Antarctica. They emerge from an underground lake filled with a special kind of bacteria. These little organisms use sulfates as fuel instead of sugars, which makes them very intriguing for scientists. The water contained in this lake is so full of iron that it basically just rusts when it meets the air. Hence, the reddish color of the waterfall, which also gives it its trademark name. Okay, we all know the song, but it's not really made up. There is actually such a thing called a desert rose. It's not a plant though, but a unique form of the mineral gypsum. It develops in dry sandy places that can occasionally flood. This constant switching between a wet and dry environment lets the gypsum crystals emerge between grains of sand, trapping them and forming a rose-like shape. Ever heard of the Eye of Sahara? Scientists are still trying to figure out how it was formed. You can only see it if you fly above it, but it's basically a naturally formed dome that dates back to approximately 100 million years ago. And no, I wasn't around then. It has a rough diameter of 25 miles and consists of a bunch of concentric rings. The biggest one, or the central area, measures about 19 miles in diameter. Astronauts were some of the first people to notice it, and it's been studied ever since. In fact, even to this day, when landing in Florida, they know they're almost home when they see the Eye of Sahara. One of the most beautifully colored trees in the world is located in the Philippines and Indonesia. It's called the rainbow eucalyptus. It got its name because of its bark that switches colors and peels away as the tree ages. The bright green bark is the youngest, as it contains a substance called chlorophyll, usually found in leaves. It then switches to purple and then to the color red. And finally, it turns brown as it grows and loses the chlorophyll. Now, don't be tricked into thinking that's a whole forest. It's one single tree. And no, it's not some sort of optical illusion either. Let me explain. Underneath that soil, there is a complex network of roots that connects around 47,000 tree-like shapes you see above the ground. It's called the quaking aspen. Some of these trees are among the oldest and largest organisms in the world. Now, here's a good destination for all travelers, or maybe not so good after all. The most lightning-stricken area in the world, according to recent data released by NASA, is Lake Maracaibo in Venezuela. Out of all the days in a year, 300 of them feature thunderstorms in this location. What makes this area so unique, though, that storms happen so often? Well, it's because where cool mountain air meets the warm, moist breeze and generates electricity over the lake. The Eternal Flame Falls are located in upstate New York, near the Canadian border. In this region, there is a tiny waterfall with a big secret, a spark about 8 inches tall. Turns out there's a natural gas seep that provides fuel to the flame behind the waterfall. The waterfall provides enough coverage so that it stays lit pretty much every time. Hikers do enjoy to relight it if they see that it's been blown out. This phenomenon is actually quite common, but this one gained more popularity because it is younger than most. And it looks very good in pictures, let's be honest. I've heard of yellow sand, white sand, and even black sand here or there. But I've never heard of green beaches until now. Papacolia, also known as Green Sand Beach, is located in Hawaii and is one of the few beaches in the world that features green sand. The unique coloring comes from olivine rock that was formed when a nearby volcano erupted. Actually, in Hawaii, all the volcanoes are nearby. Move over green sands because some of the other beaches around the world can even glow at night. And it's completely natural. The culprit? A little thing called photoplankton, or microalgae as they're sometimes called. They're basically little plants that contain chlorophyll and need sunlight in order to live and grow. Most photoplankton kinds are able to float in the upper part of the ocean, where the sunlight can still reach them beneath the water. When the photoplankton gets agitated by the movement of waves and currents, they emit light, which looks like some glow during the night. These special microorganisms are found on beaches in a lot of places around the world, such as the Maldives, Puerto Rico, and the Everglades. At the base of a mountain located just outside of Afton, Wyoming, is a little river called the Intermittent Spring. There are only 3 of this kind in the whole world, but what makes this little string of water so mysterious? Well, the fact that it starts and stops every few minutes. Scientists have yet to pinpoint precisely why this happens. They speculate that it's basically just a siphon effect that happens deep within the ground that causes the river to just start and stop so often. Should you ever be interested in checking it out, be sure to do so in the late summer, as that's when the intermittent spring is most active. Do you see the irony here? You can only see the spring in the summer? Okay, I'm done.
Is the Big Apple getting a little too heavy for its own good? A recent study revealed that New York City is sinking. And get this, it's all because of those towering skyscrapers. Apparently, the whole event is called subsidence, which is when the Earth's surface settles bit by bit, or suddenly sinks. Soft sediments shifting and the weight of the city itself are the culprits behind this sinking sensation. Now, don't get too alarmed. The study found that New York is sinking at a rate of 0.04 to 0.07 inches per year. Sure, that doesn't sound like much, but there are parts of the city that are sinking even faster than that. This sinking situation could cause some trouble for the city, especially since it's already pretty low-lying and home to over 8 million people. So it's important that local authorities come up with some strategies to tackle the growing flood risk and rising sea levels. Although, I'm not sure building giant seawalls is the way to go. We might need to get a little more creative than that. Geologists want to make sure we're all aware that building more high-rises near the coast, rivers, or lakes could contribute to future flood risks. So we really need to think twice before we start constructing skyscrapers left and right. In recent studies, scientists calculated the total mass of all the buildings in New York City, over 1 million of them, and it adds up to a whopping 1.68 trillion pounds. Talk about a heavy load. Now, they didn't include the weight of the roads, sidewalks, bridges, and other paved areas, so you can only imagine how much more weight is added to the city. But hey, even with these limitations, the researchers did a pretty good job of accounting for the complex geology beneath New York, including the sand, silt, clay deposits, and good old bedrock. They found out that certain types of soil, like clay and artificial fill, are more prone to subsidence. On the other hand, bedrock stays pretty firm and keeps those skyscrapers in place. So at least we don't have to worry about the Empire State Building taking a dive anytime soon. Comparing their fancy models with satellite data, the researchers created a map of the city showing where the sinking is happening. And guess what? The increased urbanization and all that groundwater pumping and draining are only making things worse. It's high time we start protecting our resources, don't you think? I wouldn't start packing my bags just yet. New York isn't the only sinking city out there, you know. Jakarta, the capital of Indonesia, is facing some serious sinking action too. In fact, parts of it could be underwater by 2050. That's like a real-life Atlantis situation. Over 30 million people in Jakarta are now deciding if they should relocate the entire city. If there's a city out there we should worry about sinking, that's Venice for sure. But why is it so eager to take a dive, you might ask? Well, let me tell you the complex truth. You see, Venice decided to set up shop on a marshy lagoon with shoddy foundations. As time went by, the ground underneath just couldn't hold it together and started compacting like a squished marshmallow. On top of that, the city's been slurping up groundwater like it's going out of style or something. The cherry on top of this mushy cake is that the sea levels have also been slowly rising. And guess what? Those sneaky plate tectonics are having a laugh by shoving the Adriatic plate under the Apennine Mountains, giving Venice an extra push downward. Someone had the bright idea to stop pumping groundwater, thinking they could stop the sinking shenanigans. But hold your gondolas. A new study revealed that the sinking hasn't completely stopped, just slowed down a bit. It turns out the whole area is tilting ever so slightly to the east, with Venice perched on the slightly higher end. You must be wondering how much Venice sinks in a year, right? Brace yourself for this shocking revelation. It's sinking at a rate of about 0.04 to 0.07 inches a year, similar to New York. At this pace, in the next 20 years, it could sink a whopping 3 inches below sea level. To avoid turning into a Venetian fishbowl, locals are frantically building special barriers to keep the water from crashing into the lagoon. But don't hold your breath, because this project has had more delays than you'd expect. Oh, and have you noticed that charming old-style vibe in Venice? It's not just because they're fans of the vintage look. Those salty waters have been wreaking havoc on the buildings, thanks to the water levels constantly breaching the original damp proofing. Now the water's cozying up to the masonry, and the ground floors of many apartments are no longer safe enough to live in. Now, when will Venice take a dive into the abyss? It's hard to say for sure. Subsidence and rising sea levels are as slow and unpredictable as a turtle in a marathon. But experts have playfully warned that if things continue as they are, Venice could be doing the backstroke beneath the waves by 2100. Fear not, though. They're doing their best to protect this floating gem of history and culture from becoming a Hollywood disaster flick. So don't cancel that Venice day trip just yet. New Orleans has a peculiar watery situation going on too. You see, this lively place was initially built just a smidge above sea level, and now it's gradually sinking. Back in the day, when an area of the city called the French Quarter was just popping up, folks had to make do with what they had. They scored the best land they could find, but it was only about 10 feet above sea level. And let's not forget, the rest of the city is as flat as a pancake, with the areas around the French Quarter being just a hair lower. Now, even though they knew they were up against some soggy odds, the resourceful New Orleans residents did their best to elevate their houses above the flood-prone land they chose as their home. There's more. The ground beneath New Orleans is as wobbly as a plate of Jell-O. Architects had to keep things short and sweet because they feared the soil couldn't handle the weight of taller structures. They played it safe, sticking to 2 or 2.5 stories. Here's where it gets interesting. The city installed a fancy drainage system in the 1900s, thinking it would solve their water woes. And while it did help with the marshes and all, it inadvertently sucked the life out of the soil. Yep, the ground was left high and dry, without enough sediment and water to keep it steady. As a result, those former marshes sank as if they were in a quicksand competition. By the 1930s, things got even more topsy-turvy. 1/3 of the city was below sea level, and by the time Hurricane Katrina made its grand entrance, that number skyrocketed to around 50%. Oh, and here's the icing on the cake. Sea levels decided to join the party, rising faster than a helium balloon. So now, not only is New Orleans sinking, but the surrounding area is also at various degrees below sea level. So what can we do about all these sinking cities? Well, for instance, we could manage our water consumption a bit better. We can't just keep sucking groundwater out of the earth like there's no tomorrow. We've got to find new ways to quench our urban centers' thirst. Think about it. We could purify surface waters, or even turn salty seawater into a sweet solution. Of course, we'll need a boatload of energy to make it all work. Speaking of great urban water management, let me tell you about a town in Denmark called Nye. These guys have got it all figured out. They collect rainwater and use it to supply their toilets and washing machines. Talk about resourcefulness. Now that's what I call a splash of genius.
It's 9:59 a.m. when a man is jolted awake in his bed by a powerful, mysterious force. While he's trying to figure out what's going on, a giant 100-foot-tall column of water is already surging toward his hometown. In 20 minutes, most of his friends and family members will lose their lives when a sky-high wall of water sweeps away buildings, trees, and cars. And it can happen to you at any given time. It's the day after Christmas in 2004. Thousands of tourists from Europe and America are enjoying tropical beaches in Thailand, Sri Lanka, and Indonesia when a powerful undersea earthquake strikes off the western coast of northern Sumatra, Indonesia. It's a 9.3 magnitude earthquake, the most powerful ever recorded in Asia. It triggers one of the largest tsunamis in history, the Boxing Day tsunami, which will take the lives of 230,000 people within a few hours. The city of Banda Aceh in Sumatra, Indonesia, home to 260,000 people, is the closest to the earthquake's epicenter. In less than half an hour after the quake, huge 10-story tall waves crash into the city. More than 60,000 people lose their lives immediately. The destruction is so severe that almost no one in its path survives. Next, the tsunami hits Thailand. The waves, rushing at a mind-boggling 500 miles per hour across the Indian Ocean, reach the shores of Phang Nang and Phuket about 90 minutes later. Despite such a significant time gap, both locals and tourists are caught totally off guard. Many beachgoers even walk out onto the beach, curious about the strangely receding sea, only to be overtaken by a towering wall of water. Nearly 5,400 people, including 2,000 foreign tourists, won't survive that day in Thailand. An hour after Thailand, the tsunami hits southeastern India near Chennai. Debris-filled waves push miles inland, taking the lives of more than 10,000 people. Sri Lanka faces even worse devastation. The island will lose over 30,000 people, and hundreds of thousands will become homeless. The tsunami's incredible strength is evident even far away. 8 hours later, it claims its last victims in South Africa, 5,000 miles from the quake's epicenter. There, rogue waves catch swimmers off guard. Researchers from NOAA's Center for Tsunami Research explain that the destruction was due to the sheer power of the earthquake. It originated from a megathrust fault. That's where heavy ocean plates dive beneath lighter continental plates. These faults are the largest in the world and lie underwater. The 2004 earthquake ruptured a 900-mile stretch of the Indian and Australian plates, 31 miles beneath the seafloor. Plus, instead of one quick jolt, the quake lasted for 10 minutes and released an unimaginable amount of energy. During the shaking, massive sections of the seafloor moved upwards by 130 feet. That's a lot. Such a sudden movement set colossal waves rippling across the ocean. Imagine it like dropping a massive pebble into the water. The thing is, tsunami waves aren't like those surfing waves you may imagine. No, they look like a fast-moving whitewater river that floods everything in its way. If you get caught in those raging waters, it's almost impossible to survive. If the powerful currents don't pull you under, floating debris will. That's the reason why, during earthquakes, there are usually many injuries and fewer lives lost. With tsunamis, it's the opposite. There's way fewer injuries than fatalities because it's too hard to survive. Catastrophic tsunamis like the one in 2004 are rare. That's why India and Sri Lanka had no record of such disasters. This lack of experience, combined with the absence of warning systems, made the consequences of the disaster even more tragic. People didn't feel the earthquake because they were far from the epicenter. And with no natural warning signs, no official alerts, and no history of tsunamis, the waves that hit crowded coastlines had devastating effects. By the way, the Pacific Ocean, the largest ocean on Earth, is where most earthquakes and tsunamis occur. Locally damaging tsunamis strike somewhere in this ocean about once every 1 to 2 years. 76% of the recorded fatal tsunamis happened in the Pacific. And 99% of tsunami casualties are caused by local or regional tsunamis, which occur more often and hit quickly. But then a question arises: could a tsunami as devastating as the Boxing Day one happen again? Unfortunately, the answer isn't very straightforward. A warning system has indeed been established in the Indian Ocean. Its goal is to alert coastal nations of potential tsunamis. But human behavior is still a critical challenge. This became clear during a real-life test in 2012. That's when many residents of Banda Aceh, Indonesia, simply ignored evacuation towers after a tsunami warning. People never seem to learn, huh? The Indian Ocean Warning Network uses undersea pressure sensors placed near tectonic plate fault lines. These sensors detect any changes and transmit data to surface buoys, which then send it via satellite to control centers on land. Authorities analyze the information and decide whether to issue warnings and evacuate at-risk areas. Aceh, located on one of the world's most active fault lines, implemented additional safeguards. They installed sirens in coastal cities, and people get alerts on their cell phones. Plus, there are evacuation towers, reinforced concrete structures capable of holding 500 people. They are special safe zones. Authorities did test how well prepared people were. In 2009, 18 Indian Ocean countries participated in an evacuation drill, simulating a large earthquake. Thousands of coastal communities took part in this drill, and officials concluded that the exercise had been a success. Fast forward to the system's first real test in April 2012. An 8.6 magnitude undersea earthquake west of Aceh triggered tsunami warnings. And even though there were no significant waves, the whole situation revealed critical flaws. Many residents ignored evacuation towers, choosing instead to flee by car or motorbike. This led to citywide traffic jams, with people getting stranded in areas vulnerable to a potential tsunami. It was chaos. Some residents even went back to the beach to look for the signs of a tsunami, which is a life-threatening mistake. So apparently, there is still a lot of work to do when it comes to tsunami survival. But what you need to know by heart is the signs of an impending tsunami. First of all, it's severe ground shaking. Strong earthquakes near coastal areas can generate tsunamis. If you notice that water on the beach starts to recede at an alarming rate, exposing the ocean floor, reefs, and stranded fish, run. Then there might be unusual ocean sounds. Keep in mind that a loud roaring noise, resembling a train or jet engine, may accompany an approaching tsunami. If you notice any of these warning signs, Do not wait for official evacuation orders. Leave low-lying coastal areas immediately and move to higher ground as fast as possible. If you're at home, make sure your family members know about the tsunami and follow official guidance. You should remember that locally generated tsunamis may strike within minutes. You have to act quickly. If it's a distant tsunami, you may have more time to evacuate. If you don't have an opportunity to move inland, hide in high reinforced concrete buildings. Avoid staying in small buildings or homes in low-lying areas. If you're on a boat, stay offshore. Tsunami activity isn't as dangerous in deep water, so avoid returning to port during a tsunami warning. If you're already in port, check with harbor authorities for guidance. If it's possible to move to deep water, do it in an orderly manner. It may be safer for small boat owners to leave their vessel and move to higher ground. And always, prioritize moving to higher ground over saving your belongings. If you live in a coastal area, you can take some measures to protect your property in advance. Since most tsunami waves are under 10 feet, you may consider elevating your house. It can reduce damage. You can also consult an engineer to assess and reinforce your home. And finally, don't forget to protect outbuildings too, and create fences that will allow animals to reach higher ground. The strongest earthquake ever to strike east of the Mississippi River that happened over 200 years ago was never over, according to some scientists. Most earthquakes last seconds to minutes, and the official record breaker so far is a silent one in Sumatra that was going on for 32 years. This slow slip event triggered a massive quake and a tsunami. So if it's true that the New Madrid earthquake is still sending aftershocks, we'll have a new top name for this sad list. The earthquake started in December of 1811 with a powerful quake in a sparsely populated part of northeast Arkansas. They felt the shaking almost 1,000 miles away in the White House, and the tower bells were ringing in Boston, even further away. It even made the mighty Mississippi flow backward for a few minutes over new waterfalls formed by shifted ground. The town of New Madrid, Missouri, completely disappeared in the disaster. The Earth wouldn't stay still until the end of January the following year, when things got serious again. A massive quake hit, this time near the junction of the Ohio and Mississippi rivers, right in the Missouri boot heel. Geologists believe it was a rupture on the New Madrid fault, putting even more strain on the nearby Reelfoot fault. Just when people thought it couldn't get worse, another 2 weeks of trembling passed, and the Reelfoot fault snapped deep beneath New Madrid. Down in Tennessee, about 15 miles south of New Madrid, the ground uplift created Reelfoot Lake. Steamboats were chugging along the river, with thousands of trees floating and acres of woods torn apart by the quake. In St. Louis, Missouri, which is 160 miles away, buildings were badly damaged, and chimneys fell in Cincinnati, Ohio, 400 miles away. People all the way in Montreal, Canada, over 1,000 miles away, felt the earthshake. Seismologists have registered about 200 small earthquakes in the New Madrid seismic zone every year since 1974. Some researchers believe that up to 30% of those were aftershocks from those big quakes back in 1811 and 1812. In parts of the U.S. where there's not much tectonic action going on, these aftershocks could keep rumbling for years, maybe even centuries, after the big ones hit. Aftershocks are the Earth's way of releasing all that built-up stress from the main quake. When the ground shakes from the first earthquake, it puts a lot of pressure on the rocks nearby. And when those rocks can't take it anymore, they crack, causing even more shaking. That's the aftershock. And they can be pretty intense, especially right after the main quake, but weaken over time. Not all scientists agree that contemporary earthquakes have to do with those from 200 years ago. We mostly associate faults with those lines where Earth's plates meet. But there's a whole network of those right under the center of the North American plate. They're like relics from 750 million years ago, when North America was part of a supercontinent called Rodinia. When Rodinia started to break up, it left behind these rifts, weak spots in the Earth's crust that run deep beneath the modern Midwest. It could explain the earthquake action. An international team of geologists decided to take a fresh look at 3 major earthquakes that shook North America and end the debate. They used a new math method called the nearest neighbor. It says that if earthquakes are too close in space, time, and magnitude to be independent background events, then one is assumed to have triggered the other. Depending on how you look at the numbers, somewhere between 10 to 65% of the recent quakes in the region could be aftershocks of those historic earthquakes. And a huge quake that hit Charleston, South Carolina at the end of the 19th century might explain up to 72% of the earthquakes in the area since then. But not all places are the same, so the scientific debate continues. In 1774, British explorer James Cook noticed a glow in the distance. It was the volcano of Mount Yasur in Vanuatu. This bad boy had been spewing lava and ash ever since, and it's quite likely that it's been doing that for way longer. The volcano has been sitting at alert level since October 2016, which means things are really unsettled around there. They've even marked off a 2,000-foot radius around the crater to keep people safe. There have been low to moderate outbursts, shooting out ash, gas, and steam, and some bigger blasts throwing stuff outside the crater. Satellite images have picked up on some hot spots of sulfur dioxide plumes, showing that Yasur is still cooking up a big storm down there. Stromboli, one of the volcanic islands near Sicily, officially has the Guinness World Record as the longest continuously erupting volcano. It has been putting on a fiery show for over 2,400 years straight. Ancient sailors nicknamed it the Lighthouse of the Mediterranean. Most of the time, Stromboli's just spitting out spatter, but every now and then it throws in some lava flows or shoots up some moderately high fountains. Sometimes you might even catch a glimpse of steam-driven outbursts. Over 200 million years ago, the world went through a major makeover, with not 1, not 2, but 4 massive volcanic eruptions changing the game. It all happened in Rensselaer, a large chunk of island that used to be a supermassive volcano stretching across what's now British Columbia and Alaska. This volcanic activity might have helped dinosaurs grow from cat-sized critters into giants we saw in Jurassic Park. It kicked off a 2-million-year rainy season. It made the whole world hot and humid, and the dinos just loved it. Researchers dug deep into sediment layers beneath an ancient lake in China to uncover these secrets. They found traces of volcanic ash and mercury, clear signs of those epic eruptions. There were carbon signatures showing huge spikes in carbon dioxide levels, making the atmosphere toasty and the rain pouring down. It all happened in 4 separate pulses, each triggered by those monstrous volcanic blasts. There's a spot in a national park not too far away from Sydney, Australia, where a fire has been raging deep underground for at least 6,000 years. They call it Burning Mountain, and it's a coal seam fire, burning its way through a layer of coal beneath the Earth's surface. Once these underground fires start, they're pretty much impossible to put out. This ball of fire is up to 30 feet wide and extremely hot, but there's no flame, it's smoldering. The fire has been creeping along at a pace of about 3 feet per year. A local farmer first spotted it in the 19th century and thought it was a volcano. The people who have lived here for ages believe this place is sacred. They've used it for cooking and crafting tools, and tell that it started from a widow's tears or the torch of a hero. But experts think it could have been a lightning strike or coal heating up like a summer barbecue from the interaction with oxygen. Some say it might have been burning since before the dinosaurs roamed the Earth. No one knows exactly how long this mountain will burn or in what direction it'll move. Right now, the coal has enough oxygen to burn for centuries or even millennia without human intervention. The fire is heating up the mountain like a giant oven, making it crack and crumble, inviting in more oxygen to feed on. Even if humans decide to take action, these coal seam fires need truckloads of water and liquid nitrogen to tame them. Several years ago, explorers noticed that the smolder was creeping close to a cliff overlooking a little river. And depending on what the coal seam decides to do next, we could see some dramatic changes here in the coming decades. There could be flames with much more heat, or the coal seam could go deep, extinguish itself, and smolder out. You have friends over for dinner. You set your drink on the counter and go help your friend set out some desserts. When you get back, you notice the liquid in your cup. It's sloshing around and the ice cubes look like ships on a rough sea. Now you feel it too. On the ceiling, the chandelier is swinging like mad. Then you hear someone scream, "Earthquake!" The house and everything in it is rocking back and forth. You try to run for cover, but the shaking keeps you stuck in place, fighting to keep your balance. The cabinets look possessed, and glasses and dishes fly out and smash on the floor. The bookshelves topple over, and everything hanging on the walls sways and falls off. You duck under the dining room table, trying not to get hurt on all those broken dishes. Yeah, you've been through earthquakes before, but none like this. Checking your phone? Typical, no signal. You can't believe what's about to happen. The screams get louder, and suddenly the whole house collapses. The biggest earthquake ever recorded happened in Chile in 1960. Disaster came in the afternoon, just when everyone was out enjoying themselves. To cause serious, life-changing damage, you need to have a magnitude of around 7 or so on the Richter scale. This one was 9.5. This part of Chile is smack dab on the so-called Ring of Fire, the most active volcanic and seismic area in the world along the Pacific Rim. The initial shaking lasted around 10 minutes, and after 2 days, many aftershocks were still strong enough to set off a volcano in the south of the country. But that's not where it ended. The earthquake unleashed a series of tidal waves all over the Pacific Ocean, with some reaching over 80 feet high. The waves and earthquake were so strong that they even affected Hawaii, Japan, and the Philippines. It caused around $500 million $1960 worth of damage. Many were left homeless. Much of their infrastructure was smashed too. Buildings as far as the eye could see were toppled, and debris piled everywhere. Scientists estimate that this earthquake was so powerful, it shifted the Earth's axis, making our days 1.26 microseconds shorter. That might not seem like a lot, but think about it. Just one natural disaster was strong enough to make time move. Many of the coastal cities were flattened and floods were widespread. The economy spiraled downward. According to studies, if this earthquake happened today, it caused more than $20 billion in damages. So what would happen if an earthquake twice that size hit without warning? For starters, you'd likely feel the effects even further away. Tidal waves wouldn't just hit the coasts of Japan and the Philippines. They would move even further to China, Korea, Vietnam, and even Australia. And those waves would be significantly higher than 80 feet, perhaps double that. That's like 8 giraffes piled on top of each other, surfing your way. If you lived by the coast, you'd notice the waves. If you saw the water recede way back so you could practically see where all the fish call home, you'd know it was time to run. Chances are that a tsunami's heading your way. Say it really happens. You're caught under the wreckage, not knowing what's going on. You manage to free yourself and escape to the fresh air. And you're not alone, because all the houses in the neighborhood have turned into piles of bricks and rubble. The bridges have also collapsed, leaving people stranded on either side. You look around, dust yourself off, and rush to find help. Fire trucks and ambulances drive between the broken-down cars and rubble. You try to make it to your car, but the aftershocks are still hitting, and you're getting tossed to the sidewalk. With all the cell towers down, you can't call anyone on your phone. Your knees are shaking, but you manage to power through. Once you reach your car, you see it crushed under a boulder, like a giant soda can. You continue on foot and eventually reach downtown. It looks as if some giant got angry and knocked all the buildings down. You push forward and try to see if you can find some help. Without warning, your phone vibrates. You check it and see 1,000 notifications about a 20-magnitude earthquake. You're still shaking, but that's all you. The ground is still for now. Uh-oh. You hear something in the distance, racing towards you. To your right, you see tidal waves as tall as buildings charging at you. Still in shock, not knowing what to do, you now come to your senses and run. You don't even know which way to go. There's a tsunami right behind you, and in front of you are broken down buildings with rocks and concrete still falling everywhere. Wait, there's a building that's somehow still standing. You need to get on top of that thing. You reach the elevator, but it's jammed. Not surprising. You bolt up the stairs as fast as you can, tripping on broken glass and plaster, but always managing to get back up. You look out a window and see the water. It's so close. You're nearly at the top. A few more flights and whoosh. The water forces its way into the building and drags you down at least 2 floors. You can barely see anything. Still, you know you must swim up. But the water keeps forcing you downwards. After about 30 seconds, you manage to swim your way out and continue climbing to the top. You scramble to the top floor and collapse on the roof. You're safe for now. The tidal wave is still going strong, plowing its way through the ravaged city center. Your phone is now waterlogged and useless. You have a perfect 360-degree view of your town covered in water and debris. The ground starts to shake again. Maybe you'll just sit around until this is all over, waiting for the rescue helicopter. But then, a loud explosion that almost breaks your eardrums shakes the ground even more. Off in the distance, smoke is rising, and soon it covers the entire sky. Darkness hides the morning sun. That's when you can see lava shooting up into the air and landing nearby. The lava forms into a river, flowing its way into town block by block. With this much seismic movement and the high intensity of the earthquake, the world's tectonic plates have shifted so that magma is pushing its way to the surface. From the earth, steam begins to vent. Then the heat hits you. You see the magma cover the ground like a blanket, eating up every car in its way. What's worse is that the magma is melting the foundations of the buildings that managed to withstand the earthquake and the tsunami. The buildings in the distance are now sinking and collapsing into the raging lava pool that's replaced your town. One by one, every building descends. That means, the building where you're standing is also swaying. It's about to fail. That's when you see the light. You look up and see a helicopter above in the distance. You wave your arms, run around, jump, anything to get noticed. And it works. The chopper makes a few circles and finally drops you a rope ladder. As you're lifted in the chopper, you take a good look at the world below you as it wriggles around like noodles in a strainer. You land a few miles out and are immediately treated by a doctor in an emergency triage center. You were one of the lucky ones. A year later, the tsunami water has receded. The lava that flowed inland has cooled, but all that magma permanently changed the ground below it, and the whole town is gone. The disaster has thrown the entire country into a financial nightmare that'll last decades. It takes months to survey the town, making sure there's no dangerous electrical wires or busted gas pipes anywhere. They're rebuilding your town farther inland from where the old one was. In other towns, they rebuild directly over the ruins. In others, they just decide to move everyone to a nearby city.
An earthquake in Indonesia began in 1829 and lasted a mighty 32 years. It reached its climax in 1861 and hit a magnitude of around 8.5. It was caused by the tectonic plates below the island slowly clashing against each other. Researchers discovered that the quake had been building for some time after analyzing the coral in the area. They found it was being periodically exposed to the open air. That was caused by the gradual earthquake moving the land up and down. Scientists call these decades-long silent earthquakes slow slip events. A single lightning bolt can warm the air to around 54,000 degrees Fahrenheit. The heat makes the air expand quickly, creating a shock wave or boom, which we know to be thunder. There are close to 3 trillion trees on Earth. That translates to roughly around 422 trees for every person. Before humans, the number was nearer to 6 trillion. Almost 70% of the Earth's surface is covered by water, which on average is around 2.5 miles deep. 97% of Earth's volcanoes lie underwater, as well as the mid-ocean ridge, a massive mountain range that is over 40,000 miles long. Humans have mined around 190,000 tons of gold from the planet. Experts predict there is around 20% still left to be mined, but this figure is constantly changing. The world's largest active volcano is in Hawaii. Called Mauna Loa, it's over 2.5 miles above sea level. Given that most of it is underwater, the volcano's summit is a staggering 11 miles from its base. That's the same length as over 160 football fields. The highest ever recorded temperature on Earth was a sweltering 136 degrees Fahrenheit. It was recorded in El Azizia, or modern-day Libya, on September 13, 1922. The lowest temperature was a chilling minus 129 degrees Fahrenheit, recorded at Russia's Vostok station in 1983. Earth is the fifth largest planet in the solar system, behind Jupiter, Saturn, Uranus, and Neptune. It has a circumference of roughly 25,000 miles, and it would take the average person around 8,300 hours to walk around the face of the Earth. The separation between Earth's land masses would make such a trek almost impossible, though. It takes 365.25 days for the Earth to orbit the Sun. Because our calendar years only have 365 days, we add an extra leap day every 4 years to make up for the difference. Russia is the largest country on the planet, with a total area of about 6.5 million square miles. It encompasses more than 1/8 of the Earth's inhabited land area, but still has a relatively small population given its size. Earth is the only planet with one moon. Mercury and Venus have no moons, while every other planet has 2 or more. Earth is over 4 billion years old. Scientists calculate this by looking at the planet's oldest rocks, as well as meteorites that have crash-landed. They used meteorites as they were formed at the same time as Earth, when the solar system was forming. The ground we walk on is basically recycled. The planet's rock cycle turns igneous rocks to sedimentary ones, then transforms those into metamorphic rocks, and back again. Like Earth, our moon also experiences earthquakes. They're less common and intense than the ones we have, and are caused by tidal stresses. A tidal stress is basically the relationship between the gravitational pull of the moon on the Earth and that of the Earth on the moon. Despite being the fifth largest continent, Antarctica holds 70% of the planet's fresh water and about 90% of its ice. Bangkok is the most visited city in the world, boasting 23 million visitors in 2019 alone. Paris, London, Dubai, and Singapore make up the other cities in the top 5. The lowest layer of Earth's atmosphere is called the troposphere and is the reason we have weather. Sunlight heats the planet's surface, which causes warm air to rise up to the troposphere. This air then expands and cools as the air pressure decreases and sinks down, where it is then warmed by the Earth again. Coral reefs are the largest living structures on the planet, with some even being visible from space. Coral reefs hold the most species per area of any of Earth's ecosystems, even more than rainforests. Earth got its name around 1,000 years ago, and it comes from the German word meaning the ground, but there's no evidence to show who actually named it. Of all the planets, Earth is also the only one which is not named after a Greek or Roman deity. The deepest point of the ocean is the Mariana Trench. It's a whopping 7 miles below sea level. Coastlines cover about 20% of U.S. land, but are home to more than 50% of the U.S. population. The Earth isn't actually a sphere. It's more like a squished ball that bulges at the equator. The bulge is caused by the force of the Earth spinning, which makes the north and south poles slightly flat. The Earth spins on its axis, which is basically an imaginary straight line. Earth has seasons because the axis is tilted, causing the sun's rays to hit different parts of the planet more directly, depending on the time of year. If the sun was as tall as a standard door, the Earth would be around the size of a nickel. The Earth's rate of rotation is gradually decreasing. It's happening so slowly that it would take as much as 140 million years for the length of a day to increase to 25 hours.
Get equipped for any season with brand new Brightside merch. Click the link and grab your print.
The biggest animal on Earth is the Antarctic blue whale. It can reach lengths of 100 feet and weigh up to 400,000 pounds, which is around the same as 33 elephants. The temperature at the center of the Earth is around the same as the surface of the Sun, at almost 10,000 degrees Fahrenheit. Earth is around 10,000 times older than humans. Earth is around 4.5 billion years old, whereas humans have been around for, at most, 450,000 years. There are around 34,000 known species of fish. The actual number is way higher though, as a whopping 95% of our oceans still haven't been explored. America's Route 66 is longer than the journey to the Earth's core. The distance to the core is roughly 2,000 miles. Route 66 is almost 2,500 miles. The Earth is made up of three main components: the crust, the mantle, and the core, which is divided into the outer core and the inner core. Scientists have estimated that there are around 8.7 million species on the planet. Out of this, between 1 to 2 million of these species are animals. But roughly 86% of land species and 91% of fish have yet to be discovered by humans. Ancient astronomers used to think that the Earth was the center of the universe. For 2,000 years, they believed the Earth to be static, while other bodies traveled in orbit around us. In 1543, Copernicus published his sun-centered model of the solar system. Earth is the densest planet in the solar system. The density varies across its different crusts, but the planet's average density is just over 3 ounces per cubic inch. Mount Everest is the highest point on the planet. Its peak is the highest altitude above sea level at around 5.5 miles. Each year, 1 septillion crystals of snow fall on Earth. That's a trillion snowflakes. Snow covers about 31% of Earth's land area each year. Of Earth's water, only around 3% is fresh water. The other 97% is salted. Of that 3%, about 2% is frozen in ice and glaciers. So, less than 1% of the planet's fresh water is actually in lakes, rivers, and underground. The world's largest inland body of water, or lake to us normal people, is the Caspian Sea. It has an area of 140,000 miles squared. The world's deepest lake is Lake Baikal in Russia and is 5,300 feet deep. Earth's atmosphere is roughly 78% nitrogen and 21% oxygen, with small amounts of water vapor, carbon dioxide, and other gases. No other planet is believed to have this much oxygen, which explains why Earth is the only planet where life has been discovered so far. Apart from the Moon, there are 2 asteroids in co-orbital orbits with Earth, sometimes called Earth's second moon. 3753 Cruithne is an asteroid that looks like it's following the Earth in orbit, but it's actually following its own path around the Sun. 2002 AA29 is another asteroid which makes a horseshoe orbit around the Earth that draws it close to the planet every 95 years.
If you're a fan of Dr. Pimple Popper, you're probably freaking out right now, itching to squeeze out every little blackhead from those lip contours. But this is actually a hill formation that you can find in Garb, Sudan. Knowing that perhaps makes it all the more creepy because it looks like the crack in the middle is swallowing up everything around it. This black hole scenario brings to mind our next stop, Vostok Island. This eerie spot is a 59-acre coral atoll situated in the southwestern Pacific Ocean, about 400 miles northwest of Tahiti. If you check it out on Google Earth today, it looks like it's been totally blacked out, sparking all sorts of wild theories. People keep saying that this place is some top-secret base, or even a fictional island straight out of Lost. But what we see here is actually just a dense, dark green forest made up of Pisonia trees. Since nobody lives there and hardly anyone ever visits, the island is pretty much untouched by humans. This massive star, or mandala, is situated just outside Beatty, Nevada. It has got the internet all puzzled, with people trying to figure out if it's evidence of some kind of extraterrestrial activity. To add to the mystery, this spot is right by the Tonopah test range, which is also known as the famous Area 52. Despite its creepiness, it's probably just one of the thousands of crop circles that gained fame after Google Earth came along. This spiral formation right here is also located in Nevada, and it definitely looks like another chilling crop circle. But things get even stranger if you use the street view option. As you zoom in closer and closer, you'll notice that it's made up of carefully arranged rocks. This labyrinth, so to speak, is part of an open-air museum situated in the ghost town of Rhyolite. And if that's not creepy enough, take a look around and you'll see dozens of eerie men in white cloaks. Despite their lifelike appearance, these silhouettes are actually statues from an installation created by a Belgian artist in the 80s. Even stranger than stumbling upon a large circle on the ground is finding a bunch of them. Our next location in Wyoming is filled with peculiar circle structures to the point where it's hard to count them all. During the 20th century, this U.S. state shifted from a farming economy to an industrial one, dominated by the extraction of oil, gas, and coal. So, these circles are likely remnants of a tank farm. I mean, places where oil storage tanks used to be located. If you want to avoid nightmares, I highly recommend not searching for the mausoleum of Emil Becker in Poland. If you happen to find it by using the Street View mode, prepare yourself to face an abandoned place with the most terrifying sculpture there is. Oh, the creeps. Keeping on the spooky side, let's head to an isolated corner of Kazakhstan, where you can find a pentagram etched into the Earth's surface. This formation is huge, measuring roughly 1,200 feet in diameter. Before you jump to conclusions about this formation being related to some kind of underworld deity worship, it's worth noting that the pentagram actually turns out to be the outline of a park designed in the shape of a star. The star shape is marked by roadways, which are now lined with trees, making the star shape even more distinct in aerial photos. You can spot this peculiar symbol from quite a distance. At first glance, it might even resemble an otherworldly alphabet, as if a highly intelligent civilization is trying to send us an alert message. But this mystery is already solved. We are in De Hoge Veluwe, a Dutch national park located in the province of Gelderland. And these lines are actually part of the park's logo. Search for these coordinates to find what looks like a land formation straight out of an extraterrestrial landscape, or perhaps a set from Avatar. This place, located in Inner Mongolia, China, is believed to be a granite mine. But it's a bit of a mystery why it has such a striking blue tone on Google Earth. If you check it out on Microsoft Bing Maps, for example, the same location appears in a much more natural tone. In the Australian outback lies a massive geoglyph known as the Maori Man. Discovered in the late 90s, it appears to represent an indigenous Australian man hunting with a boomerang or stick. The figure stretches for more than 2 miles in length and about 1.6 miles wide. It has deep furrows carved into the ground, which adds to the complexity of its formation and origin. Despite efforts to uncover its purpose, its origin is still a mystery. This is Desert Breath, located in the Sahara. Like many things you have seen in this video, this formation also sparks speculation about it being created by extraterrestrial beings. But a quick Google search clears up that mystery. It turns out this is an art installation created by a group of 3 Greek artists back in 1997. They went all out, moving around a whopping 280,000 square feet of sand and even creating a large pool in the middle of it. Egypt still holds many mysteries, and you can explore them yourself with Google Earth. That's how some people stumbled upon this striking triangular-shaped plateau and immediately jumped to the conclusion that they discovered a hidden pyramid. However, experts quickly dashed their hopes. They believe there's no plausible explanation for a pyramid to exist in this area, located 8 miles west of the Nile Valley edge in Upper Egypt. This discovery is likely nothing more than a hill that has suffered the effects of erosion, combined with a heavy dose of wishful thinking. In some cases, nature itself is responsible for creating frightening sculptures, like the Badlands Guardian in Alberta, Canada. If you look at it from above, you'll notice not one, but 2 human heads emerging from the landscape. These gigantic beings were sculpted by rainwater erosion on layers of clay-rich soil. Ironically, additional human-made structures give the impression that this one is wearing wired headphones. It seems that deserts are a prime spot for discovering strange images on Google Earth. So our next stop is China. In the Gobi Desert, you'll come across zigzagging white lines that look kind of random. The first challenge for armchair experts was figuring out what these structures were made of, as it's hard to tell if they're painted on or dug into the landscape. There's still a lot of speculation about it on the internet. But the most plausible explanation is that this structure is used for calibrating satellites. This way, satellite cameras can focus on these large grids to orient themselves in space. Check out this intact plane that seems to have sunk beneath the ocean off the coast of Crooked Island, Bahamas. Some viral videos claim it's a crashed plane belonging to the infamous Pablo Escobar. The truth is that something lying on the bottom of the ocean can't be that visible, so it's more likely that it's a plane that was actually flying when Google captured these images. However, there is a strong belief that Pablo Escobar did have a plane that crashed nearby, but it was in another part of the Bahamas known as Norman's Cay. You can still spot it in shallow turquoise waters. Just search for Norman's Cay sunken plane, and there it is. If you're convinced that extraterrestrials are already among us, then go ahead and type in these coordinates on Google Earth. Explore the area using Street View, and wow, what is it? Of course, we're not talking about visitors from other planets, but this shadow of a gigantic creature still gives me the creeps. Turns out, it's just a person lugging around one of those 360-degree Street View cameras tucked away in a trekker backpack. So hey, if you take a good look around Google Earth, you might stumble upon more of these elongated necked beings walking around the globe.
You step on the surface of the moon. It's unusual. You definitely feel lighter here, and it's easier to walk. You decide to check out that obsessive idea of yours. Jump on Earth's natural satellite. And even despite your bulky spacesuit, you literally fly up into the air. Woohoo! Anyway, you continue your walk on the surface of the moon when you feel something strange. The ground under your feet is it shaking? It feels as if an earthquake has just started on the moon. But that's simply impossible. Or is it? Surprisingly, your gut feeling hasn't let you down this time. Moonquakes do exist. In fact, there are 4 types of moonquakes that are strong enough to be detected from a large distance. There are deep moonquakes occurring more than 430 miles below the surface. Then there are meteoroid impacts. Thermoquakes occur when the frigid lunar crust expands. It happens when the morning sun illuminates the satellite after a 2-week-long deep freeze lunar night. And there are also shallow moonquakes. They're the only ones that are similar to earthquakes on our planet. Shallow moonquakes happen 12 to 19 miles below the surface, and they're the most powerful and dangerous. Between 1972 and 1977, the Apollo Seismic Network recorded 28 such moonquakes, and some of them measured more than 5 on the Richter scale. On Earth, such an earthquake is strong enough to crack plaster and move heavy furniture. Plus, shallow moonquakes are very long-lasting in compared to earthquakes. Once they get going, they can continue for up to 10 minutes. As for the average earthquake, it typically continues for 10 to 30 seconds. Scientists are still not sure what causes shallow moonquakes, and even where exactly they occur. One of the theories is that moonquakes happen at the rims of large, relatively young craters that probably slump from time to time. Interestingly, the Moon and Earth aren't the only places where earthquakes occur. No, scientists have recorded quakes, tremors, vibrations, and shakes in other regions of our solar system too. Let's take Mercury, for example. A few years ago, scientists discovered that this planet was shrinking, and that's why it seems to be so tectonically active. Or Venus. This world is a tectonic puzzle for experts. At the moment, Venus has no tectonic plates, and it might have never had them. But its surface has folds and faults and looks as if it could have tectonic plates. On the other hand, these features might have appeared because of other processes, for example, volcanic activity. But even though we haven't observed any Venus quakes, scientists believe they could detect them since their vibration seems to ripple through the thick atmosphere of the planet. Now, Mars. We know for sure that this planet is seismically active. NASA's lander placed a seismometer on the surface of the red planet, and in 2019, it managed to measure its first Mars quake. After that, the lander continued to record quakes, but they were so weak that if they happened on our planet, they'd be completely covered by the background noise of Earth's oceans. But a space body doesn't have to be a full-fledged planet to have active tectonics. Let's take Pluto. This dwarf planet is geologically active at the moment. In 2014, NASA's New Horizons spacecraft was flying through the Pluto system when it recorded complex geological features on this dwarf planet. Scientists concluded that Pluto might have quakes, or should I call them Pluto quakes, when its liquid water ocean freezes and thaws beneath the dwarf planet's icy crust. Jupiter's moons, Europa and Io, as well as Saturn's moons, Titan and Enceladus, are also geologically active despite their small size. Their features range from volcanoes and water plumes to potential subsurface oceans. Now, I bet you don't know these cool facts about earthquakes that occur on our planet. There's one place on Earth where a whopping 90% of all earthquakes occur. It's called the Ring of Fire, and it stretches around the Pacific Ocean from New Zealand all the way to South America. Looks to me more like a horseshoe. Anyway, experts claim that these countless earthquakes are caused by the abundance of volcanoes in that region and the constant movement of the tectonic plates. Around 500,000 earthquakes happen on Earth every year, but many of them occur very, very deep in the Earth's crust, and only special equipment can detect them. We feel around 20% of earthquakes, and only 100 of them can cause damage. The largest recorded earthquake occurred in Chile in May 1960. It was a magnitude 9.5 on the Richter scale. It was truly devastating. During that earthquake, seismographs detected and recorded seismic waves that traveled all over the world. They shook the planet for many days. As for the most powerful earthquake that occurred in the U.S., it was 9.2 and happened in Alaska. By the way, Alaska, along with California, is the most earthquake-prone state in the U.S. and one of the most seismically active regions in the world. A magnitude 7 earthquake occurs there almost every year. A mega-earthquake can actually shorten the length of a day for the entire planet. NASA claims that really large earthquakes can shift our planet's axis and, thus, change the duration of a day. Now, of course, you won't notice it since this change is measured in microseconds, and 1 microsecond is 1/millionth of a second. Scientists think that the 9.1 Sumatra earthquake, which occurred in 2004, shortened the day by 6.8 microseconds. Now, not even the best specialists can predict an earthquake. That's mostly because the mechanisms that trigger earthquakes are extremely deep underground. But these days, people have learned how to figure out a more precise time frame of when an earthquake might occur. Earthquakes can be triggered by volcanic eruptions or, let's say, meteor impacts, but most of them are caused by the movements of our planet's tectonic plates. Earth's surface consists of 15 to 20 constantly moving tectonic plates. Pressure increases when they shift, and this can make the crust of our planet break. San Francisco is moving toward Los Angeles right at this moment. The speed of its movement is about 2 inches per year. That's as fast as your fingernails grow. It's happening because the two sides of the San Andreas Fault, which is the continental fault extending 750 miles through California, are slipping past each other. So, in several million years, Los Angeles and San Francisco will be neighbors. Lakes, ponds, and canals become slightly warmer and start to stink before an earthquake. It happens because gases get released when tectonic plates shift. Most animals feel these signs and change their behavior. For example, scientists noted toads completely disappearing before an earthquake in Italy in 2009. But as soon as the natural disaster was over, they returned. Even after an earthquake is over, you might still see water sloshing around in your swimming pool. There's no need to worry. This is a phenomenon called a seiche. The water can keep sloshing around for hours after the earthquake is over. For example, the pool at the University of Arizona lost some water from a seiche caused by an earthquake in Mexico that occurred 1,200 miles away. On February 27, 2010, a massive earthquake started in Chile. It measured 8.8 on the Richter scale. As a result, Earth's crust in that region was ripped so dramatically that a city called Concepcion moved 10 feet to the west. Another earthquake resulted in the tallest mountain in the world, Everest, shrinking by 1 inch. It happened in 2015 when a magnitude 7.5 earthquake caused several Himalayan mountains to decrease in size. The Japanese used to believe that earthquakes were caused by namizu, a giant catfish that lives submerged in the mud under the Japanese islands. The fish would thrash about, causing seismic activity. As for the ancient Greeks, they were sure that a powerful sea deity, Poseidon, produced earthquakes by hitting his trident against the earth when he was angry. According to Hindu mythology, 8 elephants hold Earth in place. They are, in turn, balanced on the back of a ginormous turtle, standing on the coils of an even larger snake. And every time any of these animals moves, an earthquake occurs. You're in the middle of the Sahara. You see a huge awning with a red target pattern. Its surface is so hot you could fry food on it. A drop of water is to hit the center of this target at the speed of light. Theoretically and technically, this experiment is impossible to conduct. But if it happens, then mysterious nothing awaits us. And each version of this nothing will be different. So we'll do 3 drops. Option 1. It's better to do it from a great height or space. You take off on a jetpack into the stratosphere. You have a bottle of water in your hand. You pour out 1 drop. Let's say it starts accelerating itself. In this case, even at a low speed, a drop of water will burn up in the protective layers of the atmosphere. In less than a second, the drop will turn to vapor. Let's say our planet had no such protection as the atmosphere. The air resistance would still get rid of the drop. The drop is flying down at a tremendous speed. The cold wind turns it into an icicle. The greater the drop velocity is, the stronger the air resistance is. The drop is moving faster and faster, soon reaching the speed of sound. Then, it just smashes into thousands of small particles. Under such conditions, the drop will never be able to reach the Earth at the speed of light. Nothing happens because nothing gets to the target. The next attempt involves changing the drop. Oxygen, carbon dioxide, ozone, and other gases in the atmosphere destroy any falling object. But what if the drop didn't meet all these obstacles? You change the internal structure of water chemically. So, you put your jetpack on again and grab a bottle of water. At the height of the Earth's orbit, you open it and pour out 1 drop. It accelerates and there's no resistance. It passes through the hottest layers of the atmosphere, but doesn't burn, passing the freezing temperature, but doesn't freeze up. It flies to the ground, developing the speed of light, and crashes again. But nothing happens. The drop got the properties of a light particle, a photon. It's only under such condition that it might develop the speed we need. No object with mass, be it a car, a house, a tree, an ant, a single air, a grain of sand, or a molecule, can reach the speed of light. Only light particles are capable of it since they don't have mass. An intangible drop falls into the center of the target, and again, nothing happens. The third option. Scientists found a way to accelerate a drop to the required speed. They also have to change the molecular composition of water, making it more resistant to high and low temperatures. To make the drop reach the speed of light without any damage, you need to place it in a perfect vacuum. No air resistance, no protective layers of the atmosphere. We leave only space and the water. For this purpose, scientists need to build a long pipe. In the center of the Sahara, around the same target, people create a scientific center. From here, the pipe should go up. Its height is approximately the distance to the International Space Station. That's 254 miles, which is about the height of 50 Everest mountains. You can't connect to the ISS itself as it's moving all the time. It revolves around the Earth, completing 1 revolution in 90 minutes. That's why astrophysicists and engineers should build a small station designed for one person, and this station should move parallel to a single point on the ground. The vacuum tube is made of solid stainless materials so that rain and high temperature couldn't destroy it. Inside, it's an alloy of titanium and graphene, the most durable metal on Earth. The pipe is built horizontally. Then, with the help of several helicopters and cables, it's placed in an upright position and attached to a small space station. The pipe is equipped with small pumps that pump the air out and block its flow inside. The water drop shouldn't touch the walls, so there's a special layer of gravity plates. They push the water away from the pipe surface, using the power of magnetism and sound waves. You put on a jetpack and fly to the station with a bottle of upgraded durable water. Your hands are shaking with excitement. Your breathing sounds loud in the spacesuit. You open the bottle, tilt it slightly, and pour one drop into a special box. Inside this container, the drop gets charged with the energy needed to develop the speed of light. Now it's ready for the journey. You look at the box, close your eyes, and press the start button. The drop flies into the pipe at a great speed. From the powerful blast wave, the entire station is thrown to the side. The drop accelerates, and at this point, the pipe made of the strongest metals on Earth begins to melt like ice cream. There's so much energy in the water now that it would be enough to provide electricity to a small city. And now the drop reaches the speed of light, which is 186,000 miles per second. The pipe turns to dust. It doesn't matter whether the drop hits the ground or not, because there will be nothing. Literally, all material objects, cars, houses, fields, oceans, computers, planes, ships, flowers, trees, should I go on, will disappear. Intangible things, such as gas, air, radio waves, electromagnetic radiation, billions of terabytes of digital information, all this will also be gone. Boy, are you in trouble. Any sound, shouting, music, the phone ringing, will be impossible to create and hear. The light will disappear, and then there will be complete darkness. But let's rewind time and see exactly what happened right now. It won't work, though, because there's no time either. Imagine time as a stormy river that flows rapidly in one direction. Then this river falls into an endless pit and disappears completely. All this happened because a drop of water crashed into our planet at the speed of light. As soon as a drop begins to approach the needed speed, it loses its properties of water. It's now the most powerful and heaviest object in the universe. The energy that comes from it destroys everything for hundreds of thousands of miles. Concrete, ground, rocks, etc., 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 and on and on and on. Everything disappears. In the first second, it all gets shattered into millions of tiny pieces. Then these pieces are torn apart into millions of even smaller particles. The molecules burn up. Imagine a paper map of the world. If you wet it and tear it, it will turn into wet paper scraps. If you burn it, then part of the map will turn to ashes, and the other part will simply fly into the air in the form of smoke. The map will remain, but it will never look the same. But if you destroy the map's molecules, it's safe to say that the map never existed. There's no trace of its existence. The same thing happens to our planet. The energy coming from a drop of water makes the Earth never exist in space. And now the drop exceeds the speed of light. A black hole starts evolving. It expands and absorbs all the space debris. Then the Moon. Soon it will be the turn of Mars and all the other planets in our solar system. The black hole expands and increases the force of gravity inside it. Together with our planet, it absorbs light. It's getting closer and closer to the Sun. Our star splits into strips of light as if it had passed through a huge cosmic shredder. The Sun explodes and spits out an impossible amount of energy. It's believed that black holes appear after the explosion of stars. Right now, all the solar energy is being absorbed by our black hole. It's getting pitch black. The light from distant stars falls directly into the supermassive infinity. Meteorites flying within a radius of hundreds of thousands of miles around are also devoured into the unknown. There are many black holes in space, but only one of them was created by a small drop of water. The higher the speed of any object, the heavier it gets. Mass is the amount of energy that an object has. When water molecules reach the speed of light, their mass begins to grow, and there are no limits to this. It becomes infinite. An infinite mass forms a black hole. It absorbs everything, and nobody knows what's inside the black hole. All that remains is darkness and the unimaginable force of gravity. So I'm guessing here that we probably should not be doing this experiment, should we? How about we make a baking soda volcano instead? Whoa, something doesn't feel right. everything seems shaky. It's definitely not an earthquake, and it's actually getting worse. The clouds seem to move quicker than usual, and the animals are going into a frenzy. The news anchor pops up on the TV in an alarmed tone and says, "Good morning. We're sorry to interrupt your program. Scientists have just discovered that the Earth's rotation has been fluctuating at an unusual rate. A group of specialists believe that the Earth is increasing its rotation with every second, and they don't know why." Even if the Earth increased its speed by 1 mile per hour, the day would only get shorter by a minute and a half or so. We wouldn't really feel it, and you could go on like nothing is happening. But as the Earth spins faster, our bodies, which are adjusted to a 24-hour timing, will have a hard time trying to cope with it. If you live by the equator, that means the rotation of the Earth is going quicker than at the North and South Pole. The area by the equator needs more time in order to complete its full rotation from the starting point. You'll experience more rain than usual. The Earth's rotation keeps the weather consistent and balanced so that nothing abnormal happens. But because the Earth is moving so fast, the weather is acting up. We'll start to see more storms and more cozy days inside, sipping on hot cocoa. Even though it seems weird, everyone can go about their day. But if the Earth picked up some speed and moved at 150 feet per second, the day would be reduced to only 22 hours. It kind of makes you feel jet-lagged 24/7. Every business works with the 24 hours a day schedule, so taking away even 2 hours can have catastrophic effects on the world economy. The whole calendar will have to change and adjust to the new timing. Clock designs will change with the new midnight, replaced with 10 o'clock. And with each week, the hours will shorten, so there will be no proper way of telling time except by sunsets and sunrises. The weather will continue to get worse and worse, feeling like the rain will never stop. The animals that rely on weather patterns won't know how to function, and mass migrations will occur from almost all species of animals. Flocks of birds will be flying everywhere and reach places they normally won't go to, affecting the whole food chain and ecology. Woods, jungles, and other places where animals roam are kept in proper balance when unaffected by humans. If it constantly rains in certain areas, then floods will force animals to move to other territories and compete with the predators in the area. If the Earth picked up speed every day, then standing on a scale in the Arctic would tell you weigh 180 pounds. But around the equator, you might weigh about 179 pounds. That's because of the extra force opposing gravity in that area. With the Earth spinning faster, all airlines around the world stop, since the radar systems have gone haywire and the weather is too dangerous to fly. Everyone has to get around by car. Satellites are positioned in such a way that it's crucial they remain where they are in order to bounce signals to us. Because of what's happening, Wi-Fi and TV signals can't go through. Communications around the world will end up short and slow, and eventually we'll have a total communication blackout. Ships will cease to operate and global trading will collapse, adding extra damage to the already failing world economy. Winds will get stronger and faster than usual, which means temperatures will change. Storms like hurricanes will be stronger than ever and have more energy for destruction. And still, at 100 miles per hour, the equator will now be swallowed up in the water. The Amazon basin and small islands will now completely submerge in water by around 50 feet. Most of the plant life will be endangered, especially by the equator. With woods threatened by floods, more animal environments will be in jeopardy. The trees and plants won't survive so much flooding. If the Earth rotated so fast that the hours would now be reduced to 15, then we'd probably feel like we're always on a jet plane going through turbulence. It would be impossible to sleep if the Earth kept picking up speed every second of the day. So days would be around 7 hours long as well as nights. The whole world would be flooded, except for the highest points and the tallest mountains. If that happens, humans will most likely end up there clinging to the last remaining clear patches of land. Most of the animal life will be extinct as well. And as the Earth is spinning faster and faster, the crust will lose its durability, allowing more frequent and stronger earthquakes to happen. Volcanoes will erupt all over, even if they're submerged in water. It'll go on like this for quite a while. Many major natural disasters like earthquakes, tsunamis, volcanoes, and even melting ice sheets have sped up the speed of the Earth by milliseconds. So, with the Earth's continuing speed increasing, these natural disasters will make the planet go even faster. Even if it's just for milliseconds, it's enough to have major consequences. The Earth is now spinning at 1,000 miles per hour, and as you're sitting with the rest of the survivors, you feel yourself levitating slightly. You'll see tiny pebbles and rocks floating inches from the ground. The clouds above you are passing like shooting stars. The air is thick with moisture, since water is rising to the top, forming thick clouds ready to pour. But since gravity is weaker, some of the rain is suspended in the air. Many small objects will be floating around as if you were in space. The days and nights won't be longer than a few hours. At this point, the whole world will be flooded, and the crust will be 80% gone. If it goes on any longer, there won't be any living things around, probably except for microscopic creatures that can withstand extreme and harsh conditions. The Earth would need to spin at approximately 17,600 miles per hour to cancel out the gravity for things to start floating around. At this point, all the water in the ocean will rise and look like reverse rain. The large mountain rocks will separate from the bedrock and levitate above the ground, looking like little planets in space. The Earth is now spinning 17 times faster than usual, which makes one full rotation around its axis only 84 minutes instead of 24 hours. If you manage to stay that long, then you'll literally see the days and nights go by in an instant. You'll also be floating aimlessly in the sky, bumping into rocks and other surfaces. You won't recognize anything anymore. The Earth's crust is ripping apart, exposing the magma underneath. So landing on the ground isn't an option. You'll see outer space as you go higher and higher. You won't know how fast you're going, but all you know is that you're probably the only human left in this spinning world. The Earth will eventually spin so fast that the rest of the layers will start to peel off, exposing the Earth's interior. It'll start to squeeze itself from the core until it becomes similar to a pancake. Nothing can survive at this point. So much heat will be produced from the core that the planet will heat up like a microwave. All the water will disappear, and it'll look like a red dot in the solar system. And once it starts to approach the speed of light, time will freeze. The rocks and floating elements won't move and will eventually be distorted. And with enough effort, the Earth will eventually turn into a black hole. Of course, nothing like this will ever happen. According to scientists, Earth will most likely slow down in rotation. Ever since the Moon came into the picture, the Earth has been slowing down by around 4 miles per hour every 10 million years or so. That's because of the Moon's gravitational pull on our little blue planet. It'll most likely go on that way. So hey, what's your hurry? Electronic satellites suddenly go out of control. There are voltage surges across the globe. In some places, there's a complete blackout. Scientists have little data on this incredible solar behavior, so we're still unable to accurately predict how or when exactly the next geomagnetic storm will happen. One such event took place back in July 2012, but thankfully it missed us. Not by far, though, by a mere 9 days. Just to give you a glimpse of what nearly happened, I need to explain some astronomical basics. A solar storm is a series of effects we feel here on Earth after certain events occur on the Sun. Our star is nothing more than a huge ball of molten gases that are constantly moving around, so these events happen more often than you'd think. For a solar storm to begin, our Sun needs to emit bursts of energy. They're in the form of solar flares and coronal mass ejections. These two phenomena send electrical charges and waves of magnetic fields toward the Earth at an astonishing speed of about 3 million miles per hour. When these solar storms reach our planet, we can see northern lights display in locations close to the Arctic Circle. But they can also mess up satellites or other types of electronic communications. Some of these solar storms can be dangerous, and back in 2012, we came close to experiencing a very powerful one that could have had a serious outcome. The most powerful in as much as 150-plus years, based on research done by astronomers. But how did we manage to escape it? Did we have something to do with it, or was it just a pure coincidence? What we do know is that one of those coronal mass ejections did hit the Earth's orbit in late July 2012. Our planet had already left that specific location as it was on its scheduled trajectory around the Sun. So you might be asking yourself at this point, what if it didn't miss us? Turns out these intense solar storms are dangerous to all sorts of technological objects. Given we are now literally surrounded by electric objects, from our phones to our cars, try to imagine what would happen if they all stopped working all of a sudden. And here's how they work. Solar storms start with an explosion, or a solar flare. Then X-rays and UV radiation travel to our Earth at the speed of light. Some of the side effects? Well, they can include radio blackouts and GPS navigation errors. The effects can continue as minutes, or at times hours later, energetic particles reach our atmosphere. They move only a bit slower than the speed of light, but they can electrically shock the Earth's satellites and damage their components. Lastly, about a day later, clouds of magnetized plasma reach us as well. They can cause huge power blackouts, more or less paralyzing everything with an electrical plug. We might not even be able to flush our toilets, since most water supplies in cities use electric pumps these days. The effects of these geomagnetic storms would be different around the world, though. Solar storms are curious by themselves, but why do they affect some locations on Earth more than others? Based on recent research, geology has a lot to do with it. But I need to take you back a bit to paint you the bigger picture. Buckle up, because we're taking a trip in the time machine to a time when the moon didn't even exist yet. 4.6 billion years ago, our solar system looked a lot different than it does now, and that's putting it lightly. Hundreds of new planets began to form around the new sun. Planets like our own Earth, Venus, or Mars were still hurtling around the cosmos. Back in the 1970s, an astronomer named Donald R. Davis developed a theory that said the moon was born when another planet hit a newly formed Earth about 4.5 billion years ago. He also indicated that it might have been the size of Mars and later named this planet Theia. It's difficult to imagine what that impact might have looked like, even with the equipment we have these days. The astronomers suggested the giant impact hypothesis, trying to piece together this mystery. After running into our planet, the outer rocky layers of both Earth and Theia were projected into a circle of cosmic matter. Out of this debris, what we now know as the Moon was born. The Earth's core has apparently consumed Theia's iron core, that is, if it had any. Our planet also got into the position it occupies today. This way, it became more susceptible to geomagnetic storms. Back then, there was little to no information as to what might have happened to Theia, apart from giving us our only natural satellite. It took several years for a series of scientists to come up with an exciting new idea that revolutionized what we knew about our planet. What was left out of Theia is hiding under two continent-sized layers of rock deep within our planet. This theory is also one of the only explanations for why the Moon is so dry and doesn't have much of an iron core. But why is geology so important when it comes to geomagnetic storms? Well, that's because recent data revealed that the type of rocks below your feet can affect how well your city adapts after powerful geomagnetic storms. Some types of rock, like sedimentary rocks for example, generally have more space filled with water, which makes them electrically conductive. Other types of rocks are denser and have more resistance when it comes to electricity. Whenever such a storm happens, People living in the New England Highlands may have a higher risk of experiencing major disruptions. At the same time, those in the mid-Atlantic coastal plain have less to worry about, simply due to what's hidden beneath their cities. How did we know how scary these storms are? Well, this wasn't the first time it happened. Solar storms have dazzled the astronomer community for many years now. The most iconic event of this magnitude was the Carrington event, which happened way back in September 1859. It gave us a sneak peek of what the power of the Sun is, to say the least. They named it after an English astronomer, Richard Carrington, who witnessed the solar flares himself. The power of that solar storm was something humans had never experienced before. The strong geomagnetic storm caused northern lights as far down south as the territory of Hawaii. On the morning of September 1, 1859, Richard Carrington made his way into his private observatory, located outside of London. He opened the observatory dome to have a complete view of the sky and directed his telescope to the location of the Sun. He saw a bunch of huge dark spots that gleamed on the surface of our star. Shortly enough, Carrington noticed two enigmatic areas, intensely bright and full of white light bursting out from the sunspots. They disappeared 5 minutes later, but the effects carried on all across the Earth's surface. At first, later in the night, telegraph communications all around the world started to malfunction. Flashes of light started to burst from telegraph machines, disturbing the operators and even setting papers on fire. Brightly colored auroras started to appear in the nighttime skies all over the world, making confused birds chirp at night. Some people even began their daily activities, since they mistakenly thought the day had already begun. These days, our planet is laced with a mega information web, so the impact of such a solar storm would be even messier. Back in the 1800s, the telegraph system was just starting out, but this Victorian internet was an important way of sending news and private messages. Even in the United States, telegraph operators had noticed local interruptions because of thunderstorms and northern lights before. But the Carrington event and its effects were something they had never seen before. A lot of telegraph lines in North America became useless. One telegraph manager based in Pittsburgh even recalled that the currents flowing through the wires were so strong, their platinum contacts were in danger of melting. Another example was that of a telegraph operator located in Washington, D.C., named Frederick W. Royce, who was hurt as his forehead touched a ground wire. Samples taken from the Earth's icy locations tell us that the Carrington effect was twice as big as any other solar storm experienced in the last 500 years. It's very difficult to imagine what the impact of a storm of that magnitude might be today. But based on a 2008 report drafted by the National Academy of Sciences, it might cost us between $1 trillion and $2 trillion in damages. There are things we can do individually to help reduce the amount of damage, though, like buying a generator or installing a backup energy supply. This can be either a solar panel or a wind turbine. More so, we can equip our houses with surge protectors that connect to our electrical panels and can save us from lightning and other power surges. The simplest solution of them all? Just unplug all the devices you're not using at any particular moment. If they aren't connected to a power source, they can't be affected by any surges.
Our planet has known terrible floods, powerful tornadoes, destructive hurricanes. Those dangerous natural disasters are familiar to us. Just picture this. Winds howling through the atmosphere at about 500 miles per hour, and they can stick around for weeks. These insane winds have the potential to damage the ozone layer, making our Earth a hostile place for life. It's not some wild Netflix dystopia. These are real-life hypercanes. A hypercane is a hypothetical extreme tropical cyclone the likes of which we've never known. To kick off a cyclone, the sea surface temps have to hit around 122 degrees Fahrenheit, basically hot enough to sear a rare steak. It's tough to imagine, especially since that's nearly 22 degrees hotter than the highest ocean temperature ever recorded. Yep, the hottest ocean water ever was recorded in Kuwait in July 2020. What could cause such a serious increase in temperature? A powerful comet or asteroid impact, an eruption of a supervolcano, or a large underwater eruption. There's even a theory that a series of hypercanes could have sped up the demise of non-avian dinos after the infamous asteroid impact. An important difference between a hypercane and any present-day hurricane is that a hypercane would rise as far as the upper stratosphere. That's up to 25 to 35 miles over the surface of our planet. Meanwhile, present-day hurricanes only go as high as the lower stratosphere, up to 6 miles above Earth. It would make a dramatic, catastrophic difference, but we'll talk more about it later. Hypercanes could gust to 600 miles per hour. For comparison, the most powerful recorded tropical cyclone in terms of maximum sustained winds was Hurricane Patricia. At its peak, it reached a speed of 215 miles per hour. This speed pales in comparison with that of a hypercane. Can you imagine how much destruction such a natural disaster could cause? Should they ever form, hypercanes will also have an enormous lifespan. They could rage for a couple of weeks, if not more. Extremely low pressure inside hypercanes would support massive storm systems the size of North America. At the same time, hypercanes could be as small as 15 miles across. Such relatively tiny formations would lose their strength in no time after wandering into colder waters. On the other hand, the waters after a hypercane could hypothetically remain hot for weeks, hot enough for more hypercanes to form. Since a hypercane would reach far up into the stratosphere, there would be a real chance it could damage Earth's ozone layer. And it would have devastating consequences for life on our planet. The ozone layer absorbs some of the harmful radiation from the sun, preventing it from reaching the planet's surface. Let's just hope to never see a hypercane in our lifetime. Another potential disaster that could seriously harm Earth could be the activity of our very own sun. I mean a massive solar flare. Few natural disasters can wreak as much global havoc. A solar flare wouldn't destroy buildings like a tsunami or earthquake. It wouldn't end lives in the same way an asteroid or a supervolcano would. But if the worst comes to the worst, it would destroy the entire electronic infrastructure of our planet. Recovering from the consequences of this catastrophe would cost trillions of dollars. An incredibly powerful solar flare could cause loads of infrastructures to fail, including communication, medicine, banking systems, and transportation. Earth would be left without electricity for a long time, and people wouldn't be able to reboot the already broken power grids. Water supply systems would be out of order. There would be no food in supermarkets. In 1859, people in different parts of the world woke up in the middle of the night because it was so light outside, they thought it was already morning. The skies were illuminated with colorful auroras. They showed up even in the regions where no one had seen them before, like the Bahamas, Hawaii, or Jamaica. Telegraphs got electrically charged, even though they were disconnected. Fires started in many regions. In other words, the consequences were already catastrophic, even when technology barely existed. Imagine the avalanche of problems a solar flare could trigger today. Then there are gamma-ray bursts. You can't come across this kind of radiation in your everyday life. A gamma-ray burst occurs when two neutron stars collide when a massive star collapses. Gamma rays could turn into a serious danger to our home planet. If a gamma-ray burst happened close to Earth, it would likely rip our ozone layer away. And you already know how crucial this layer is. Plus, gamma rays could create ground ozone. This kind of ozone could seep into the ocean since it's water-soluble, and that would lead to a mass extinction of marine life and plants. According to some theories, if a gamma-ray burst occurred within around 200 light-years away from Earth and its jets were pointed directly at us, our planet would be vaporized. If the distance was greater, but still in the Milky Way, the resulting radiation would sterilize all life on the side of the Earth pointing towards the burst. Another catastrophe that could potentially destroy our planet might be a super eruption, an eruption of a supervolcano. Yellowstone Park is located on top of one of those. The last massive eruption in that region happened about 664,000 years ago. The next eruption might be due anytime soon. Luckily, at the moment, there's no evidence that the supervolcano is waking up or getting ready for an eruption. But if it did happen, a massive column of lava and ash would shoot up into the air to a height of several miles. The volcano would keep pumping ash for days on end. But the most dangerous consequences of the eruption for all living creatures would be ash fallout. Buildings and trees would collapse under the weight of this dense substance. In just a couple of days, a 10-foot layer of ash would cover the territory of 50 miles around the center of the eruption. After the ash got into the stratosphere, the temperatures would start to drop all over the world. The eruption would most likely be rich in sulfur, an effective sunblocker. So soon it would get so cold that there would be no summer in the entire world for a few following years. It would be hard for animals to find food and clean water. Earth could also encounter a wandering black hole, a region in space where gravity is so powerful that not even light can escape its clutches. At the moment, the nearest to us black hole is around 1,500 light-years away. Seems like there's nothing to worry about. Well, until you find out about wandering black holes. Now things definitely get creepier. If such a black hole entered the solar system, Earth would be doomed. Recently, for the first time ever, astronomers have found a solitary wandering black hole in our home galaxy. This space traveler is 7.1 times as massive as the Sun and is now 5,200 light-years away. Scientists discovered wandering black holes before, but those were in other galaxies. This one is the first to pop up in the Milky Way. Giant sinkholes could also swallow entire communities. For example, when one of such sinkholes opened up in the city of New York in the summer of 2022, it pulled a parked van into the earth. And it wasn't the only sinkhole in that area. Local inhabitants reported around 4,000 sinkholes all over the city between July 2021 and June 2022. This kind of problem is also very common in Florida, and it's much more serious than it may sound. Sinkholes open all of a sudden, pulling down everything and everyone that happens to be nearby. Sinkholes appear all over the world. They're totally unpredictable and form without warning. Luckily, experts know what causes them. In some regions, there are vast areas of groundwater. But during droughts, this water dries up, which creates large, empty caverns. After heavy rains, the surface over such a cavern is likely to collapse, creating a sink.